if it does not contain module offset, contains key, print new coverage. Man, I'm making so many typos. We're just gonna call this. Now we're gonna leave that. We're gonna do new coverage, sim off. Should just be a string. Then we're going to do coverage db or input db dot. We might need to hash these inputs, otherwise we're not gonna have a reasonable way of deduping them. So I think we can just do, we can do a hash set of arc vec fuzzer actions. Technically they don't need to be arcs, we can just do it in RC. So we'll pull that in as well. Okay, 87 type strings. Wow. Struggling. I don't know what green happening. I don't know. I think my my Twitch is having some issues. I think you guys are still there. I'm just I lost my like Firefox kind of died on me. Okay, we can get music back. All right. Looks like everything is still up and running. Cool. Okay. Yeah, it looks like Firefox oomed. Because this like compiling failed here. What the fuck is using that much RAM? Oh, Procmon. I got Procmon running. Maybe that's why Spy++ wasn't working, because I had Procmon up. So we can close this edge, close this. Those we can leave open. The VMs are fine, they use no RAM. So Procmon, I bet that's going to take a while to exit. No, there we go. Oh, much better. Okay. Okay. So that, I can go to 91. Hash set. That should be fine. And then we'll pull in a hash set here as well. And then down at 91. Doesn't like that. This is a hash set. And then this is now going to be, let's do type fuzz input is equal to an RC vec of this. And boom. Okay. Yep. So now we have to go over to the other project. I'm actually gonna do a Windows split here. Fuzz source this, and then fuzzer action. We need to implement partial EQ, EQ partial, ord, and hash. Okay, 136. Expected in arc. That's fine. We can. Really? Should be able to. I mean, I can just clone it. I don't really care. It's basically free. And then we're gonna do input db dot insert. Let fuzz input is equal to an RC new containing the genres. And we want to do that here. So that is the fuzz input. Then in here, we're going to do a clone. And then in here, we'll do a insert of a module dot clone offset. Then we'll do fuzz input dot clone for the value. Note that these clones are just increasing ref counts. They're not actually creating copies of strings. Expected RC. What? 137. I typoed something somewhere. Ah, yes. So, module offset, fuzz input. Offset we can steal as well. I'm pretty sure I can just deref this. And offset here. Yep. So we will. Okay. So this is going to go through, and that will debug exited. Genres, we go through, we insert all of these things, and then here, I can say, yeah, new coverage. Why is that not printing? We're not loading mesos. Okay. So now I think we should be collecting coverage information. No. Where is the meso file? .meso. Okay, so now we have applied the breakpoints. We're getting code coverage on these fuzz cases, and we're able to go through, and we see a bunch of new coverage events, of course, and then detaches and exits. Cool. So now what I can do is we'll have to start writing a mutator shortly and sim off. So we can print that off for new coverage. And we can get rid of this break. I just want to see if this is working. So this should now basically have everything sync up. And then once it's all synced, it'll just go to a new fuzz case. Hopefully. That's the dream. Debuggy exited. So in this case, the debuggy exited, but the thread has not decided to die. We might have to just pass in like a flag in there to stop it. So it might eventually get stuck in that sort of state. So, trying to think through the best way to do this. Maybe I can kill process after debuggy exited. SP lib source debugger terminate process. So we'll just do this on dbg.process handle. I think it's fine if we fail to kill it. We can just ignore the results of that. And we definitely won't have those scoped. So let's go, and if it's not equal to 0 is the failure case. We're going to add a new routine to the debugger. Pub fn kill. Mute self. Technically doesn't need to be mutable. Kill the process via terminate process. Unsafe. Process handle unwrap. This. And then we can return an IO. Result this. If this is equal to 0, then we will get the error. that. I should eventually memorize that. That would speed up some coding. Okay, and then I don't know if we have IO here. We don't. Okay. I'm just organizing these. I hate when they're not in order. I try to do them. I try to group them by Rust standard libraries, then followed by external crates, such that I have a better idea of where to approximately look for problems that come up. Coverage, hash map, not found in the scope. What did I break? Did I lose some? Oh, yeah. Oops. Oh, that was just a long line going that way. Okay. Terminate process. 130. Really? What? Oh, yeah, here. dbg.kill. Okay, so this will now run. It'll make sure that it tries to kill it. We just ignore the kill state. So in this case, yeah, this is kind of weird. It exited, which means that we tried to kill it, but for some reason it's still alive. And it's pretty stuck right now. That's interesting, because if I control C, it definitely dies. I don't know if there's a more aggressive thing than terminate process. Is there something more aggressive? Must have process terminate access, right? Yeah, we do. Initiates termination and returns immediately. Unconditionally cause it to exit. May be compromised if terminate process is used. Execution of all threads. Request cancellation of all IO. Huh. That's going to be a little bit of an issue. I mean, we could maybe put in a thread and kill the thread that owns it. So there it exited. We got new coverage. Now we're going to run through. We're going to fuzz some stuff. And then once that's done... Okay, so... Oh, yeah, that's stuck again. What is causing that? Terminate process. dbg. I think I might know the issue. I think what I can do is let coverage is equal to this. Hash map new. So we're gonna basically steal the coverage from the debugger once it's exited. Then we're going to... This is now coverage.iter, and at this point we can do standard mem drop debugger, which should hopefully cause the debugger to detach and all of that stuff to happen. Mute that. That swap debugger.coverage and it'll reference to coverage. So hopefully that fixes our issue. That means the debugger will be dropped, which will hopefully release any resources that the debugger has open with the calculator application. Yeah. So now we saw slightly less new coverage, new fuzz case, very little new coverage, so on and so forth. So we're getting to a good point where now we're starting to see we're starting to be able to kind of watch the coverage differential. So we'll see if this case, yeah, that generated new coverage. Cool. So now we have a good idea of roughly what generates new coverage and what doesn't. So we can now make this coverage guided. We're gonna get rid of some of these prints because our confidence is going up in our tool. New coverage at SimOff. We don't need that. SP lib source. What's coverage? Code coverage is effectively a mechanism, or not a mechanism. It is the information about where in the application has been executed by the process. So, for example, this is telling us that this function was executed at this offset, this function was executed at this offset, and it allows us to see roughly how much of the application we're stressing with a given fuzz case. And that's important for us such that we can kind of go back and save this coverage and use this as feedback and send this to a developer or a researcher or the developer of the fuzzer to color a graph to see roughly where they're missing coverage or missing fuzz cases. So it's mainly just used as a metric to determine what is going on in the application when we're putting random inputs into it. That should disable prints and mesos. Actually, that's going to cause some unused code issues. We're just going to put this as format, which will just create a string. Who cares? It's not a big deal. SimOff is no longer used at 138. Yeah. Okay, so I want to get rid of these 64-bit. So there are some prints in here that are not M prints. We can get rid of, I mean, we can just make that an M print, I think. What about the other print? Space print. M print that. I think that's fine. 1047. Okay. So this needs to take a self. Okay, so now we don't get any printouts at all. I think I'm gonna take a couple bites of my food. Be right back. All right. Now we should really have no prints. Okay. Calc went away, came back, no prints, looks good. Okay, so now what we can do is, man, these fuzz cases are slow. GUI fuzz, yeah, it's cool. Slide that away for a second. Okay, down here we're gonna do for fuzz case in 0u64 ... basically count from 1 to infinity. Well, 64-bit, it's infinity. Let the fuzz case in. And then this is going to be start time is equal to instant now. So this is going to be get the current time. Use standard time duration instant. I don't think we need duration actually here. And I think Rust just added a new API for getting the time as an F64 on a duration. As seconds F64. Yeah, stable as of 1.38. So that just went stable. I'm so excited. I manually had to implement this basically every single piece of code I've ever written for the past, like, 5 years. Because I'm always getting the time or like the elapsed time as a floating point. I'm super excited for this. Oh, this is exciting. Okay, so this is going to be like statistics gathering. Let uptime is equal to instant now minus start time as floating point 64. So now I can do print up. We'll do 12.2 uptime. And then we'll do 7 fuzz cases. So we've got uptime, we've got fuzz cases. We're gonna do 8 coverage. And we'll do a 5 inputs. So this will be coverage db.len, input db.len. We'll put some square brackets here. We'll do 10. We're gonna do 10.6 for this. Okay. And this is gonna be fuzz case as F64 divided by uptime. Nice. Okay, so now we should have statistics about our fuzzer. There we go. So it's been 7.5 seconds. We have 1 fuzz case. We're getting 1 fuzz case every 7.5 seconds. Our coverage number and the number of unique inputs in the input database. So we're not doing feedback yet, so we still haven't made any improvements. But now we're in like a good state. It seems that the application is consistently exiting. If we control C, everything comes down. So that looks pretty solid. What are the numbers inside the print doing? Is it some format thingy? The numbers, oh, yeah. So basically the 7 is saying print 7 digits and pad them with spaces. So it allows these to line up even if these counts change. Like in this case, the whole display didn't get skewed over to a side when this went from a 4-digit number to a 5-digit number. This is really important to me. If I don't have vertical alignment, it's very hard to like read and diff and compare these things. So, yeah. So here we can see coverage kind of plateaued. Like this fuzz case got very little new coverage. These ones did. So now we can actually check in on this guy. Okay. Yeah. So that... I think Windows is broken. Okay. Nice. So I guess we're gonna maybe be able to shut this down cleanly. Yep. Nothing to see here. We might have to forcibly kill this. The disk should be synced. There's no reason it wouldn't be synced, so I think we're safe here. Yeah, I think this one's going in the trash can. Oh. I can't even forcibly turn it off. Okay. Okay. Nothing to see here. Everything's fine. Just a normal day with 80 instances of crashed calculator. Okay. Let's see if anything showed up. Looks like another one of these kind of showed up, but we didn't see the CO, which is kind of interesting. There might be something that we've decreased in quality from the previous fuzzer. Maybe we do need key presses. Maybe we need to play with weights. Shit happens. Sometimes making your fuzzer better makes it worse. I mean, in this case, we find a lot more bugs a lot faster, but we're not finding the same bugs we found before, which is really not that big of a deal. Because we did the old fuzzer. We can always... If you ever make your fuzzer worse, it doesn't matter, because you can just adopt whatever concepts you were using in the prior one in combination with the improvements that you've made. So there's never really a loss in fuzzer development, which is kind of nice. So that's up and running. Let me see if... I'm trying to think how I want to scale this out. I think all of my servers right now are running Linux. So I could set up like KVM on one of them and set up a Windows VM. I might have a Windows disk that I can swap into some of the servers. Okay. But I'll show you why that matters. So effectively, what we can do now is when we call generator, instead of passing it nothing, we're going to pass it a PID. And we're no longer going to attach to a window by name. I opened the same file. Whoops. So all we need to do is find the equivalent of this. That is attach, we're going to call this PID. Find a return a window object for the processes main window for the PID main. There we go. I think usize. Don't need this crap anymore. And we need to find a way to get the primary window for a find window process ID. Window handle from process ID. Oh, shit. Are we gonna have to enumerate windows? TID in the PID. Get window thread process ID. What's this? That gets the PID from a window and a thread. Like, I know it makes sense because Windows has like many windows per process ID, but I'm looking for like, I just want the first one. Find a process ID by window handle. Oh, that's an output. My bad. So, no, that is by. I want the other way. I want get HMND from process ID. And yeah, I do think it has to be an enumeration. Which makes sense. So basically, son of a bitch. So this is going to be enumerate window procs. So we're going to enumerate procs. We're going to go through. So we're going to have to hop into win bindings. We'll just kind of flip these down. And we're going to do function enum windows. This takes in a... Yeah, so I think we're going to just search for all calculator windows and then search for the process. I guess we can just search all windows. It doesn't matter. Enumerate windows proc. Let's make sure this works on only top level. Okay. And then the callback is going to be a type. Callback for enum windows. Extern C function wind lparam. It's going to return a bool. This is going to take func and an lparam. Returns a bool. Okay, and is that it? Is that seriously okay? I was expecting some like parameters. All right. So we're gonna attach PID. We're gonna do an unsafe enum windows. We're gonna have to make a local function that implements the exact same procedure as this. So it's gonna be enum windows handler wind usize lparam usize returns a bool, return a true from here, and this should give us HMD here, and then we can do enumerate windows of self : this the 0, and if that fails, then we return an error. Okay, and we're just gonna panic here. Figure that out later. Return. So if we fail to enumerate windows, we do that. Otherwise, we panic. Generator, one argument expected. This is going to be attached PID. Now I'm going to pass the PID into here. And then this will take debug.pid. I think I can do that. Not quite. Private field, not a method. Lib source. And we'll go into here and PID. We're just gonna make that public. And 129. Expected U size, found U32. Okay, then this guy should be a U32. So should this guy. Of course that can't be sent. So we're gonna do let PID is equal to this. We're just making a copy of it such that we can send it in that thread. At the end, we got to foo. We did enumerate all these windows. Okay, and now we can say we have to pass in some yeah, we got to pass in some metadata into this. So we need to do let metadata equals. We're just going to call this context. We're going to do PID, and we're going to want some way to get out an option. And that option, so we're going to take in a PID and an option, and the type of the option is just going to be it's going to be a U size for the window handle. So we'll pass an immutable reference to this as mute this as usize. So convert that to a usize so we can pass it to the Windows function. And then on the other side, we're going to unwrap that, and we're going to get let param is equal to unsafe l param as mute this. Okay, so we've cast that to a pointer to that, and then we make a mutable copy of it. And then we just need to make another API call. This. Get window thread process ID. So I guess it puts the process ID here and then returns the thread there. Okay. Function. So this takes in a wind. It gives out a process ID as a U32. We can do mute U32, and then it returns a U32 as well. Okay. I don't know how we check for failure. I guess it can't fail, maybe? I don't... Questionable. I feel like the documentation used to cover stuff better than this. I don't know if this has been, like, changed. That's weird. I don't like it. So here we're going to pass in the handle to the window. We're going to do another unsafe block here so we can do this call. We're going to get access to... Actually, I think this whole thing we might be making unsafe. Wind. Then this is going to be the PID. And let the TID is equal to this. Sure, we'll break out unsafe. Never hurts. Be unsafe. Get this into here. Let mute PID is equal to 0. We're going to assert that PID is not equal to 0 and TID is not equal to 0. I don't know if that's an error case, but I think that's good enough. That will basically say if this hasn't been updated by the function, we're just going to assume it failed. And then we're going to return true to continue your enumeration. Actually, if param.pid is equal to pid, print found pid at this, and then we'll do param dot, I guess it's just param dot 0 is the pid, and param dot 1 is going to be this. Here we can return false to kill the enumeration, and here we return true. So keep enumerating, stop enumerating. Okay. And this should be set to a sum. And then we basically determine if it succeeds. Sum wind. And then we're going to assert param.1.is none. This is kind of making sure that the API is behaving and that it is actually stopping after we stop the enumeration. Cannot borrow is mutable context. Yep. Okay. That looks good. Found PID here. Sweet. Sweet. So now we can do a, let's just do a if let sum wind is equal to context.1, else error. We'll just do this, even though it's not technically accurate. We're just fuck it. We're gonna do it right. I always forget how to make the error. It's like error : new error kind : other comma something. On IO error. This. We can do IO here and IO here. Error kind, and this is could not find wind for PID. Don't need a semi. Then here, I think all we do is just return a new OK of, and I can move these down. I can do an OK, which contains a self, which, what goes in a self? I think just a wind. A wind. Now I'm like kind of hooked on saying. I actually get a little excited when I get to say wind now. So we're gonna make a new self object, which is a window, which has a wind in it, and that's it. So we can do a one-liner. Create the window objects. Could not find a wind. All right. Son of a bitch. It's, where are we at? Unwrap failed on 130. Expect error on generator. Generator. Okay. If not, enum windows. Let's see if it's getting here. We're just gonna say like woot. It's filling here. Okay. Let's look into the return code for this. I'm guessing it might be possible for, yeah, maybe it's possible that it returns, it fails, the return value is 0. Okay, yeah, if it's not failed. If that returns 0, Okay, so if that returns 0, it's also 0. So I guess we'll just do this then. Basically, this will make it use the first one. I guess we could just keep overriding it and use the last one. It doesn't really matter. So we got to woot. Looks good. We attached to that. Fantastic. Okay. Okay, so we don't need found PID anymore. We do want the woot, though. Where did we put woot? We put that in GUI fuzz source win bindings. Woot. Okay. So now we're attaching based on a PID. So we're finding the window. Obviously it's working because we're sending all of our inputs and we're doing fuzzing stuff. Looks great. Okay, gathering coverage. Fantastic. So we can move that up, and then we're gonna make a worker. And this is gonna take in a statistics structure. And this is where all of the statistics are gonna be held for fuzz cases. So this will have fuzz cases, which will be a U64 number of fuzz cases. Then we're gonna have our coverage databases and input databases here. So we have coverage DB of this type, an input DB of this type. Oops. We're just going to call this a coverage database. Maps, module offset to fuzz inputs. Okay. Set of all unique inputs. So fuzz input, we're gonna have to convert all of these to arcs. Okay, looks good. 30, fuzz input not found. Move it up. Okay, that looks good. Derive default. Then what are we gonna do? Worker is basically gonna get everything from here. Then we're gonna clean this up. So that'll eventually call worker. We'll figure out what information we need in here. This is now the local coverage database. Actually, we're just gonna have a local stats database. And this is gonna be let mute stats. Local stats is equal to statistics default. This can now loop forever. We're gonna go down here. Local stats coverage database, input database. Print the local length there. That statistic stuff is eventually gonna move. Down here we'll do local stats dot fuzz cases plus equals 1. And let fuzz case equals. Now we can get that for the stats. Okay, now we have this verbose shit. I don't think we need this. We don't need any of this. Load the mesos. In this case, we're always spawning a process. Let debug is equal to this. Spawn, false. argv is just gonna be went through to calc.exe. Create a new calc instance. What else you got for me? Mesos. Okay. Get rid of all this shit. See ya. I guess we're just using the debugger now. 8.3 input database not found. Of course not. We're gonna do this too. God, that's really unreadable at that point. I need to find a better way to format that. Went to do calc, found string, or wanted string. Have your string. 59 expected a path. That's really sad that I'm not using asref on that API. I need to fix that in Mesos. 99. Input database.len. This is local stats. Input database 132 calc. Oops. 56 expected string. Didn't I do a dot into? I might have undone that somehow. Wait, I undid everything there. I have no idea what button I just hit. Okay, 59 cannot borrow is mutable. Fine. Debugger's now mutable. Done. Mod load handler we're no longer hitting. That's for like dynamic meso loading. Workers never used. We can spin up a worker. 54. Okay, spin up the fuzzer thread. Extra kill the debuggy. Swap coverage with the debugger and drop it so that the debugger disconnects its resources from. I'm getting better at that. That's like the last thing that I fuck up so frequently. Debugger disconnects its resources from the debuggy so it can exit. Connect to the fuzzer thread and get the results. Wrap up the fuzz input in an RC. Go through all coverage entries in the coverage database and check if this coverage entry is something we've never seen before. Coverage entry is new. Update the fuzz input in the input database, or save the fuzz input in the input database, and that we only need to do if it's not already in there. So, I mean, it doesn't matter. It can overwrite it because we're working with RCs here. And now this is update the module plus offset in the coverage database to reflect that this input caused this coverage to occur. Update the fuzz case count. We're going to take these statistics. We're going to bring these out here. We're going to do for in 0.4. Standard thread, spawn, move a worker into there. Then we're going to let mute let stats is equal to statistics default. This is now the global statistics. Spawn threads. We're gonna have to wrap this in an arc. New mutex, new. We don't really need to bother with doing like fast atomics here because the perf is just gonna be pretty trash anyways. So RC, anywhere where we use an RC needs to become an arc. And that looks good. Okay, start time we no longer have. So we'll do let start time is instant now. Save the current time, spawn threads. So this is going to need to make a copy of stats specific for this thread, and then we're going to hand the stats structure. Oops. We're going to hand it into the thread. Looks good. Expect failed to launch thread. Some quotes down here. We're going to do standard. This will be a loop. Thread sleep duration from millis 1000. Let stats is equal to stats.lock.unwrap. Get access to the global stats. Good. Okay. Okay, 30, worker defined here. This is now going to take stats, which will be an arc mutex of statistics. And then down here, if it's unique to us, then we're going to run basically the exact same logic. So let's call this key. Let key is equal to this. So we can search for a reference to key, and then down here we can do key.clone. Now we can nest again and say stats is equal to stats.lock.unwrap. Get access to global stats. Then here we'll do basically the exact same logic. If the stats.coverage db.contains key, then we're going to update this in the global stats as well. Save input to global input database. Save coverage to global coverage database. Okay. 93, lock is a function. 121. Couldn't do an expect on a join handle. Okay. Okay, we're gonna go up to this. This needs to, that doesn't need to be mutable. The one at 93, this one needs to be mutable. Looks good. 35, start time, not used. Good. Bye. Okay, so this should spin up 4 calcs, fuzz all of them separately, and then globally save all of the statistics into one big database. Except for fuzz cases. So we gotta do stats.lock.unwrap.fuzz cases plus equal 1. The fuzz cases are slow enough that we don't really need to bother with like doing an atomic for it. So we're just gonna grab the lock. There we go, we got 4 cases completed. We've got counts of the coverage and the inputs. This looks pretty good. All right. So now we have what looks to be a lot more of a real fuzzer. We haven't done code coverage feedback yet, but we've now made what I would consider to be like pretty standard fuzzing interface. Like I write this code a million times. Like this is basically like just writing the same stuff that I've written a million times over and over because it's just perfect. I need the uptime, I want my fuzz cases, I want the speed of fuzzing, I want coverage information, and I want the number of unique inputs in my input database. That's all I care about. So this is kind of an interesting database structure. So effectively, the way that this logic works is we create a new statistic structure here. We wrap it in a mutex, which makes it shareable mutably between multiple threads because it's guarded by a mutex, an actual lock. And then we wrap it in an arc that allows us to copy the mutex and share it around. The arc is just atomically reference counted. So basically, atomically reference counted means that this mutex, which is stored in the heap, will not get freed until all users of this stat structure are gone. So if I didn't wrap this in an arc, I couldn't pass it into this thread because it's possible that this thread could exit and then free the mutex, and now you have use after free. So that's why you have to wrap it in an arc and a mutex. I get the current uptime. I make a copy of the stats. So this stats.clone is all it's going to do is it's going to make a new arc object and update that internal reference count. And then I'm going to send that off to the worker thread. So I'm going to like give this, I'm going to move it to the worker thread. Then down here, we just sleep for a second. So that's the frequency that we print to the screen with our fuzz case information. We get access to the database. Since everything is scoped here, this lock expires at the end of the loop scope. So basically, we lock it for as short as time as possible, only during the print. We don't want to lock it prior to the sleep. Otherwise, we'd hold the lock forever, effectively. So then we compute how long we've been up by subtracting the current time from the start time, get that in seconds, and then we just print all these statistics out. So this is just the uptime, number of fuzz cases that have completed, basically the amount of times calculator has been launched and exited, the number of fuzz cases we're getting per second, the unique amount of coverage inputs in the database, and then, or the unique amount of coverage entries in the database, and then the unique amount of inputs. So what you can see here is that coverage is kind of plateaued. Like for here, we did a couple fuzz cases that never increased coverage information. So feedback will hopefully feedback some more relevant information from complex fuzz cases to increase the chance that we do those things again. So we're going to start working on a mutator. Let's check in on how our fuzzer is doing. 1, 2, 3, 4. It looks like the same. Nothing new. That's fine. We're gonna make this one better. So fuzz cases, seconds, and then the other thing that I want is crashes and unique crashes. So here we have the crashes that are being saved out. I might need to add something into my SB. What do I need to do? I need to go into the libs, debugger, source, debugger, and I think I might need to create a callback for when a crash occurs. Got crash here, remove breakpoints, take a full mini dump, and then I think I might invoke a callback here. If I set up a callback, that would potentially allow me to... Actually, we're going to return out of this with an exception code. So the .run. This should return an exception code, potentially. We're just going to say if let exit code is equal to this. Yeah, I think that's how I programmed it, is that that returns the exit code. And we're going to say, here, we'll get the global stats here. Do global stats, let stats is equal to stats lock on wrap, stats here. And then we'll say if exit code is equal to if exit code is equal to C005 access violation local stats dot crashes plus equals 1. And then the global stats crashes update crash information, and then down here we'll just put crashes as U64 because we'll have that many number of crashes. It's important to note that this is not the number of unique crashes. It's just a statistic. So this we will do stats.crashes. Yeah. Comparison is useless due to lifetime. Really? 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 It was because of the signedness. So we should be fine now. Hey, King Jasper. How's it going? Is the NL for Netherlands? Are you a Netherlands viewer? Well, I'm glad you're here. Good old Kiwis. Whoa. My whole screen went black there. That was not me. I did nothing. Like, I did not hit a key or a mouse button or do anything. Is Rust hard to learn? You know what? As someone who loves Rust and likes preaching about Rust, it's really fucking hard. It's an exceptionally hard language. It is probably the hardest language I've ever learned over C++. Now, to do basic things in Rust, you can learn pretty quickly, and I would say are slightly easier than C++, but the skill cap of Rust, like when you're working with unsafe code or creating some of your own like iterators or more like Rust-like structures, the skill cap goes through the roof. It sucks. But there's really good information out there, like a Rust book, to kind of get spun up on learning Rust and all those different things. So it's not too difficult to get your foot in the door. So my first Rust project was my OS. I ported my old C OS to Rust, and that sounds like a stupid first project in a language, but by this point I'm comfortable in programming languages, and I basically wanted to see if Rust was suitable for my development experience, which is basically always doing OS development or developing things that could be put in my OS. So I decided that would be a fun first project, and I was able to port basically all of the functionality of my OS to Rust in a week. I definitely didn't do things in a Rust way. Like, I wasn't using iterators. I really didn't understand lifetimes yet. I wasn't, like, doing things correctly in Rust, but I had written basically Rust as if it's C. I wrote almost all the same, like, for loop kind of constructs. But yeah. Doesn't Rust make it a hassle to do unsafe stuff in an OS? Not at all. The unsafe stuff in Rust is plenty easy. It's about as simple as you can ask for. Yeah, it's more complex than C and C++, but C and C++'s unsafety has no requirements of basically defined behavior. So when you're writing unsafe code in Rust, you have to make sure that you don't violate any of the unsafe code or any of the Rust assumptions, all of the undefined behavior things. So unsafe code is only safe if you have no undefined behavior, or your undefined behavior corresponds directly with the Rust specification. And that's hard. You have to keep all of that in your head of like, is this unwind safe? Is this, are these lifetimes correct? Can I borrow this here? Is it safe for me to share this between a thread here? And those decisions are a lot more difficult because in C and C++, you just don't fucking care. You like just pass pointers between threads and you're like, you know what? I'll worry about the lifetime. I'll just like put a sleep in the other thread and it won't free it or something. I don't know. Maybe I just won't free it. I'll just leak it. Who cares? And in Rust, you have to be a little bit more aware of the ramifications of what you're doing and make sure you don't violate those. Is it possible to call C and C++ libraries from Rust? Yes, absolutely. A lot of this stuff is doing exactly that. Like this is a debugger using Windows APIs. The GUI fuzz stuff is using all like Windows APIs under the hood to get access to the Windows and read and write from things. And we didn't use any libraries here. We did everything directly. We just communicated directly with the OS's provided APIs, which on Windows are pretty high level. And that's it. What are you up to? Right now we're just kind of looking at this. I'm just trying to pay attention to coverage. I'm getting a rough approximation of how frequently this increases. I'm trying to get a good benchmark of what the ratio of fuzz cases to inputs are. In this case, we can see that we have about half of fuzz cases that are discarding their inputs, which is a sign that there are a lot of fuzz cases that are going through that are not generating new coverage. So I'm just kind of keeping an eye on this right now, and I'm going to cancel this in like 30 seconds. But once we cancel this, we're going to switch over and we're going to start writing a generator that will take from our input database, and it will start munging together things, and it will try to create new fuzz cases for calculator based on old historical fuzz cases that worked well. I think you should consider making a YouTube channel so that your VODs don't get lost. No problem. I got you. Go to youtube.com/GamozoLabs. Here you go. Here's the live stream that we did yesterday. Here are like live streams I did like years ago. So this stuff, yeah, I've got stuff from 7 years ago on here. So these stick around for a while. But thank you. No problem. Let's see. What is the goal? So the goal is effectively to find bugs in calculator. And if you're not familiar with more like the VR vulnerability research side, because we're looking for bugs, we're looking for crashes. So in vulnerability research, I guess I can actually say this because there might be people here who don't know VR, which is really cool. Basically, vulnerability research is looking for bugs in software, and then you typically look for bugs that are exploitable, which would be security issues, and then you can write exploits for them and kind of get code execution or control of the computer through a way that you're not supposed to. Think of them as like a really sophisticated glitch. And effectively, what we're doing is we're taking calculator, we're kind of enumerating what the UI looks like programmatically. So we're pulling up Win32Calc, which is the old school calculator in Windows. We're figuring out where all the buttons are. We're figuring out like where all the menu items are. And then we're randomly mashing buttons to like do as many interactions as we can with calculator, like a bunch of random inputs. And the goal of that is to find exceptional cases in the software where it behaves incorrectly and crashes. A crash is usually the first stage to finding an exploitable bug. Obviously, there are logic bugs that don't always necessarily crash. But in this case, we're looking for a crash to try and find corruption in calculator such that we could use a very advanced input to calculator to cause the memory to be in a certain state such that we would get code execution in calculator. And calculator itself is known in the vulnerability research community as the tool that you pop up when you land an exploit. It's kind of like the success, like I'm demonstrating that I have full control of this computer by opening an instance of calculator on the desktop. So the goal here is to kind of make a joke, make a play on top of that, where we're going to try to pop calc in calc. So yes. Are you actually sending mouse input? No, we are. So kind of. So we are sending the event to the application saying this button has been pressed. So we aren't sending a mouse input. We're not emulating mouse or doing any of that stuff. We're not looking for coordinates on the screen. We are specifically finding all of the buttons that exist on the UI, and we're sending a command directly to them. That's actually what you set up earlier today in the stream. The first 2 or 3 hours of the stream was going through to enumerate where the buttons are so we could inject those inputs to the application. Okay. So we get these stats out of here. We see roughly the crash rates and all these things. So we also, I think on crashes, we probably always want to save the input. So let's make a crash database that's going to resemble very close to the coverage database, but for crashes. And we're also going to have to get some information out of the debugger to tell us what type of crash just occurred so that we can kind of dedupe those. So we're going to add unique crashes here, number of unique crashes, right? Unique crashes, that's a very hard problem. So we're going to say unique in quotes, and we're basically going to say these are the unique events based on the file names that were generated, which is unique locations and types of accesses to memory. If people are interested, I can go through how I classify my crashes. So let's see. Now I'll have the crash DB. This will be a hash map. So can an arc string usize? No. This is going to contain just a string to a fuzz input. And this will have unique crashes. This actually won't be a thing. Unique crashes will just be the crashdb.length, because this will make them unique entries. So database of crash file names to fuzz inputs. Nice. Okay. Can you hear the music in the background? According to the DB meters, it looks like it's silent or cutting in and out. I hope that's not been cutting in and out in the background there. So in this case, we're gonna have to get a little bit more information out of debugger. Oh, you can't hear any. Okay. Yep, I thought that was a little too low. It's hard to figure out where on average, when I'm looking at the meters, I'm trying to figure out where on average it is based on the volume slider. So sorry, I've had this music up the whole time, but the main thing is I just need to make sure the ratio between my voice and the music is sane. I can't hear that ratio myself. I don't have the correct setup here. You know, given these streams seem to be going pretty well, I might actually do that. Okay, sounds good. Perfect. So let me see. Maybe there's a way for me to save this. The scene. I'm trying to make sure that I save this information for future streams. Anyways, what we're gonna do is we now are going to hop in the debugger. We're gonna look for crash : this is when a crash was found. We're gonna return out with the file name of the crash. So we're gonna just do that here. We're gonna do exit type, exit code will be one of them, and then we're gonna have crash. And for crashes, we will return out the file name. Okay. Now we have to change probably a couple places where this is used. This is now going to return an exit type. We now have to make a new public enum here. We're going to do pub enum exit type. We're going to have, man, I'm struggling. Exit code, which is 932. Program exited gracefully with a given exit code. And this is program crashed. This is crash. This will just take a string. We'll grab all these. Not going to be copy. Different types of ways the debugger run routine can return. Okay, so here we're gonna do exit code is that. Then down here we're gonna do if let exit type crash name is equal to exit code. We're gonna call that exit state. Exit state is that if it's a crash, we're gonna update the crash statistics, and then we're gonna need to pull in that exit type as well from debugger. Okay, now that we're here, we're going to, so we update these crash counters, update crash counters, check if this case ended due to a crash. And now we can do local stats.crashdb.insert crash name.clone, and we're going to insert that into stats, or whoops, we're going to insert, what is that mapping to? The fuzz case. Right? Is that what we did? Yeah. And then this is stats. Fuzz input clone, that's good, that's fine, everything's sane. This one technically doesn't need to be cloned, as that's going to be the last use of crash name. So we can take ownership of that now. Return 0, 899. Exit type, exit code, I think. Exit status, maybe. 1098. Exit type, exit code. Looks good. No exit type in the root of debugger. Okay. splibs debugger source lib. Exit type. Okay, that looks good. Now we should have those statistics, and we're saving this crash inputs, and then we're also going to make sure that the input database has the crashes input added to it as well. So crashing inputs will get fed back as well. Crash name.clone was input.clone. Oops, it's just the fuzz input. Okay, stats input database, and then local stats. Add the crashing input to the input databases. Add the crash name and corresponding fuzz input to the crash database. Can anyone can explain the differences between C++ and Rust? That's actually, I've never thought about that. I'm gonna need like a few seconds to think on a good way to answer that question. They're very different when it comes to syntax. Although they follow this similar like programming model that almost every language has. It has loops. You have for loops. You have iterators, which C++ has. C does not. stats.crashdb.len. So syntactically, it's much different than C++, but if you're comfortable and familiar with C++ or any like C-derived language or C-like language, you'll be very familiar with a lot of the concepts. You know, you have the function is declared differently instead, like, let's actually find something here. Boy, bad examples everywhere. Everything's rusty. So, like, this function, for example, I'm going to cancel this. So this function, for example, in C, would be a function that returns a value. And in this case, it's already immediately very complex because it returns an error code. So in C, you'd probably have a bool. You'd call it perform actions. This would take actions, which I don't even know how to write C anymore. This would take a fuzzer action star actions. So it would take a pointer to actions, and then it would take a length, which would be the number of actions in the actions list. Maybe it would take a vector in C++, but this is kind of more the C way of doing things. And then it would also take another argument, which would be like an error. And to like return out of this, you'd return false on an error, but you'd also, in this case, you'd update the error thing to have the right field filled in. I don't know. So syntactically, like, this is basically the same function in C and C++. So that's kind of like, they do have a lot of similarities. The type is swapped with the name of the variable, so that changes. But everything's still like semicolon at the end of lines, spaces, commas, curly braces for scopes, parens, square brackets for array indices. So it actually looks pretty similar to C++, but that's where it stops pretty soon. So Rust is a safe language, and what that means is that there's no way that in Rust, in safe Rust, that you can cause memory corruption, undefined behavior. So like the standard crash, when you see like this application has crashed, like null deref sort of things, cannot happen in Rust unless you explicitly write unsafe code. So Rust allows you to write unsafe code, which in this specific application we kind of have to use. I really wish that help windows stopped popping up so I could search. So in Rust we use some unsafe code, and unsafe code basically allows us to do things that are dangerous. So in this case, we're actually taking a usize, we're converting it to a pointer that's a window listing, we're dereffing it, and then we're converting it to a Rust mutable pointer. So we're saying like, no Rust, this is really a real pointer, and it has the correct lifetimes, and it's safe for it to exist for as long as this function scope exists. So a language like C++ does not have that at all. It's entirely on the developer to like have that always in mind when they're developing, which is stupid because it's impossible to write code without bugs. We've been writing C and C++ for 30, 40 years now, and there's never been a code base that isn't riddled with shit tons of bugs. Memory corruption bugs specifically. So Rust basically eliminates a large amount of bug classes from standard development. And to do that, the user has to be, if you're writing unsafe code, you have to be hyper aware of what you're doing. So unsafe code is like the stuff that you have to be really knowledgeable about. But if you're a standard developer in Rust, you never have to use unsafe code anyways. Like unsafe code is if you're doing OS dev. In this case, we're interacting with system APIs that are meant for C. So this is a callback that's meant for C. We're actually having a C library call into us in Rust, and then we're doing stuff in Rust and it's returning back. So there are just kind of a lot of things that fall kind of in that category. But yeah, the biggest thing that's different in Rust is it's a safe language by default. Technically, modern C++ you can write safely in, but everything's an unsafe block. So what's nice about unsafe blocks is that you can literally grep a code base in Rust for unsafe and try to identify the potential areas where dangerous behaviors could come in and security bugs at that point. So yeah, like if someone wrote a browser in Rust without any unsafe code, which is unlikely, but let's say they did, or they wrote their unsafe code correctly for the 0.01% of the code base that needs to be unsafe, there would be no memory corruption bugs. The CVEs, the vulnerabilities that you see exploited against modern browsers 50 times a year would just go away forever. So that's important, especially as a security researcher. That's important. That's an investment that I view. If you are a defensive security researcher and you're not promoting and trying and helping out, like, security researcher, your job is to, like, make whatever fucking company product you have more secure. Who cares? Like, as a security researcher, you should be focused more on, like, in general, how can you make things more secure? Because security researchers are computer engineers, and computer engineers don't stay at jobs for more than 2 years. So, I mean, obviously some do, but a lot of them hop around really fast. So that, like, specifically computer security has so much churn that, like, on a yearly basis, 30% of my friends are at new jobs, or 30% of, like, my colleagues or whatever are at new jobs. So it's kind of more important, I think, as a security researcher to actually care about security as a whole and not the security of your company, because the security of your company really won't make any progress unless security as a whole does. There's just kind of a bar. Like, the community produces tools, and I'm saying the community, not like some open source community, but like companies and businesses and people involved in security produce new tools and new ways to find bugs, research papers on interesting new bugs to be aware of, and that sort of just gets picked up by companies, and that is how software gets more secure, is we learn mistakes that we've made and we make corrections. And safe languages are really important. So Java is a safe language. Obviously, Java has a lot of bugs because it was written in an unsafe language. Rust is actually written in Rust, which gives a little bit of an advantage there, but it also doesn't have a runtime. It has a lib standard, a standard library, but it's relatively small, so it's very unlikely that something in Rust itself would hurt the security of your own application. Have you completely replaced C and C++ with Rust? Yes, I have. I did about 4 years ago. So I haven't written any... I've maybe written 5,000 lines of C in the past 4 years, where traditionally I would probably write 5,000 lines of C a week. I have no need for it. Rust just does kind of everything better. Yeah, it's harder. It takes more time to learn, but any language that's safe is going to be harder to learn, because the reason that C and C++ are so simple is because they don't care. It's very easy to have a language that doesn't have complex lifetime requirements or knowledge of race conditions or knowledge of how to wrap things in locks, when the language itself fundamentally does not care if you do your code in a safe way. So of course it's easier. You know, it's the same as saying, like, getting into a car that has no seatbelts and has no airbags and doesn't have doors and doesn't have windshields. It's, like, easier to get into because you just hop on in. But those features are there for a reason. And as someone who's been developing Rust for 4 years, yes, there are some things that bother me in the language, specifically your ability to work with binary data. It's really hard to, like, cast structures back and forth without unsafe code, even in situations where it should be safe and the language should know that. But I don't really care what language you use as long as it's safe. Write Go if you want to do Go. Go is basically just an easier version of Rust. It has a little bit higher of an overhead, but it doesn't matter. Like, the perf, it's still native. It's still better than anything you'd write in Python. That being said, Python, Java, C#, C flat, like, all these different things are viable, safe languages that everyone can use, that are tried and tested and have bindings with all C APIs and can interact with these things, and you can write OSs in them. Rust just is the closest to the system. Rust doesn't have a garbage collector, which, if you're not familiar, Basically, a garbage collector is another thread that's spun up when your application starts, and it effectively, technically it doesn't have to be a thread, but whatever. Usually it's another thread that's kind of watching the heap activity and watching for allocations, and it goes and cleans up garbage. It basically frees allocations that are no longer in use by checking ref counts, by going through and finding things that like are done in the application. So obviously that gets invoked in your process, in your current thread too, like whatever. But Rust, one thing that's difficult about a garbage collector is a garbage collector requires that your code runs in a certain operating environment. And languages like C and C++ don't have that. C and C++ you can compile, you can then rip out the text section as long as it's relocatable, place it anywhere in your processor, and just start executing out of it, and it's fine. But languages like Go start to kind of have this requirement that you have this normal runtime. You have access to APIs on a system, you have basic thread awareness and these sorts of things. And Rust has a mode called no standard, which basically means that it won't use the standard library of Rust at all. It will only use this library called libcore, and libcore has 0 OS dependencies. Not one, not a couple, not a few, 0. Which means that you can write Rust that can be compiled down and you can jump into it as an operating system without creating an environment for it to live in. Like, you can write an operating system in Go once you write a bootstrapping thing that provides enough of a suitable environment for Go to execute in, which is on its own a large part of an operating system. And I think there are ways around that in Go, so that's like not the best example. But it'd be like Python, right? Like, if you wanted to write an OS in Python, you would have to write a Python interpreter first. And that's one thing that's nice about Rust, is it just compiles down. Like, I have operating systems in Rust that are 30 lines of assembly for a bootloader, like literally real mode starting execution directly into Rust. Like, there's just, you don't have to set anything up. It's awesome. I love it. Yeah, I have so many complaints about the language, but it is at least 3 times better than any other language I've ever used. It just is. So, anyways, so we have this information kind of coming through. So the next thing that I'm going to do, which is I think required for fuzzer development, is to graph your data. Graph your fucking data so you can see what's going on. So we're going to make a quick little file here. This is going to be the fuzzer. We'll call this log, and we'll call it file create fuzz stats.txt. See, C and C++ are still there in my head, and Python, I guess. Open a log file, and then to this log file, we're going to log out the 12. We're going to do uptime in seconds, 12.0. We don't need to mark these anymore. Then we'll have fuzz cases, and then we'll have coverage, inputs, unique crashes. Actually, crashes is useful as well. So we'll do uptime, fuzz, case, coverage, basically everything here. Jeez. Okay, and this is going to be a write to log. We'll just put an unwrap on there to make sure that it wrote successfully. And then we can do log.flush as well to make sure that that gets flushed to the disk. Use standard fs file. Use standard IO sync. Actually, I think just write. I think seek is separate, but I think sync is in write. Yep, it is. So now we should be able to look at a fuzzstats.txt file. It has all of this information. And now we just want to graph this quickly. So we're going to just put in GNU plot, make a graph called plot.plot. We're going to do plot. We're going to set the X label to fuzz cases. We're going to set the Y label to coverage. And we're going to plot fuzz stats.text using the first column, which is the, that's the uptime, so we don't want that. We're using the second column, which is the fuzz case, and then we're going to plot it against the third column, which is the length of the coverage database. And we're just going to get this up and running. See you around. Have a good sleep. So we've got this up and running. We're plotting on, oh, look at that. We've like recreated almost all the bugs that I think we had, except for the one exception. Yeah, this VM is horked. Okay. I'm really tempted to disable that help menu because the only thing that keeps stealing my focus is Edge opening with help non-stop. So here we can look at a plot. So this is the coverage over time. We're going to plot this with lines. So WL is going to say with line, so it's going to connect the points. Instead of using points, it's going to use a line. And then we're going to set... I'm fighting the computer here. Log. Set log scale Y. So now we're going to have a logarithmic scale for the Y-axis. And I think this is going to fail to graph. Oops. I think this might fail to graph. Nope, there it is. It might be really unhappy with the 0 line. The fuzz case is at 0. So let me just see what happens if I do it on a time domain instead. Yeah, it seems to like that a bit more. Let me double check. Maybe I just wasn't patient with it. Oops. All right, I'm going to cancel it. Okay, looks good. This, we want 2 to 3. So fuzz cases on the x-axis. On the y-axis, we have coverage. That looks fine. And then... okay. So we can see, let's do set no key. Turn off that key. And then we'll do set terminal Windows 1000 by 900. Actually, we can do like 1500 by 900. WXT. Size. There we go. Okay, and then I think I can fix that anti-aliasing because that's driving me nuts. GNU plot. There's a way to increase kind of like the frequency of the plot points. Whatever, I forget what it is. Fuzzy edges. Can I do this? Do you think Google's smart enough? Not as good as figure from this. PostScript. What is it? Set terminal. Terminal PNG. Yeah. GNU plot. Resolution. There we go. This. I don't think this is going to necessarily work in our case because I think it's just an issue with the small amount of data we have, but this is just going to increase the amount of horizontal samples. Yeah, it didn't do shit. Okay, so coverage is obviously incredibly logarithmic here. We basically find all of our coverage and then find nothing more as the fuzz case continues. That's pretty standard. So without coverage, this is basically what your fuzzing looks like forever. Like this. Woohoo, this is fuzzing. with feedback, we're going to get some bumps in here, hopefully, where we're going to feedback interesting things, and we're going to get like an increase in coverage that's a little bit higher than normal. So what we're going to do is when we go to our generator, we're going to have a random chance in here to switch between using the generator or the mutator. So, and we're going to do that based off of the input database. So we need to, let's make this RNG public so that we can get access to it here. We're going to make an RNG for a thread. Let RNG equals RNG new. Create an RNG for this thread. Then we're going to have a random chance of whether or not we're going to generate. So generate is going to be equal to rng.rand. We're going to AND it with OXF, 1 in 16 chance of generating. And then here we're going to say if generate, then generator, else mutate. And the generator will return its stream, and in the mutate phase, it'll return that. So mutate, we're going to have to pass in some stuff there. We're going to have to figure out how we want to write that mutator. If we generate, we just do that. If we mutate, then we do that, and then we do a let mutated. And our performance is so low that we're not even going to bother with doing some like performance modifications here. We're just going to pass this in. So mutate is going to take in some existing inputs, I guess, maybe a reference to the input database. And then that's going to generate a new stream, and then we're going to perform those actions, and we're going to return out the mutated stream from there. So let's see how this looks. Fuzz input clone. Mutate not found. Yeah, so we've got generator here. We're going to make mutate. It's not going to take a PID anymore. Perform actions is now going to take a PID. PID U32. And then we're going to switch to attaching to a PID rather than doing that. It's attached to the calculator window, attach PID. Perform all the fuzzer actions, return out. Okay, so if generate, then we're going to generate, which is a 1 in 16 chance. Otherwise, we're going to call the mutate routine. Once we get the mutator result back, we then pass that to perform actions to actually start it up and do that fuzz case, and then we return the mutation back. Unexpected token actions, just need a comma. And here we're gonna do mutate. Mismatch types. Mismatch types. Yep. Okay, vec new. So that's just gonna do nothing. That means the fuzz cases are always going to time out. Expect failed to perform actions. Okay. And then RNG doesn't need to be mutable. Good. Nice. Okay. So all the calc's been up. None of these happen to be fuzzing, which is fine. So we need to add one extra case here, which is if generate or local stats.input.db.len is equal to 0. So if we don't have an existing input, then move on. Local stats. What? Oh yeah, this is in the thread. I mean, do we just give it global stats access? Yeah, why not? Why not? It's not that big of a deal. So let stats equals stats.clone. This will give access to global stats in this thread. So wait for calc to render. I can drop this down to 500 probably now. Here we can do let stats equal stats.lock .unwrap. Just perf is not a question here. Otherwise, I'd be trying to save some more cycles. Get access to the global stats database and make this mutable. Sets.clone. I need to scope this. Okay. Let the thread equal to this there. Clone the stats in here. Okay. Unclosed delimiter. Yeah, I probably fucked this up somewhere. I did. This. That. Okay, mute stats doesn't need to be mutable. Okay, so if there's a 1 in 16 chance of generating, then we generate. Or if the input database is 0, then we want to call the generator. And it seemed like that was not the case. So we are calling generator. Why is it not doing anything? Let me make sure all my calcs are closed. I'm confused. Generating. That's cool that they all had the exact same coverage information when we just launched them. That's really good to know. Oh boy. Why is that not generating anymore? We don't need that anymore. Generator attach PID. You know what? I think no, we're good there. Is it this? Because we changed that from a 500 to from 1,000 to 500? I really doubt it. Well, that's what it was, I guess. Okay. Then we got some panics. Oh, that's just because I cannot find wind for PID. Generating. Looks good. Okay. What's the issue here? Perform actions on PID. The PID should be up and running. Oh, we need to sleep here. But we're always doing that. Wait for calc to render. Wait for it. We either call generating or mutating. Generating. Why do we not see prints for the other threads? Because the lock's held. Gotta be careful with those lifetimes. Stats.lock. There we go. We've got all 4 generating. Then they probably should come back with mutation. Yeah, a couple of them are doing mutation. They're doing nothing, which is fine. I just need to see if they're going to crash. Looks like we closed them all out. Everything looks good. Yep, closing them down. Looks good. Okay. Now we're going to do perform actions on PID with the mutated buffer. We're going to want to pass in stats to mutate. Yeah, I really want to pass that local stats. Which means we're going to have to put this in an RC ref cell. Well, I guess the local stats aren't synced. We do want the global database. So we're going to do mutation. And then here, we're going to do input list is a vec of fuzz inputs. And this is just a list of all unique inputs. And input db.insert, wherever this happens, if we see if it was not inserted into the list, basically if it wasn't the first one to insert, then, or if it was the first one to insert, then stats.input list, did I call it? Push fuzz input.clone. Input list. Okay, then down here it contains key. Here we're doing the same thing. If stats db insert push it to the input list. So basically, the input list should always match the input database size, and that'll allow us to randomly pick an input by using a random number generator, rather than having to like. There's no way to randomly index something in a hash set efficiently, so we keep a list alongside of it. TLDR. Number of crashes. Input list at 32. We need a comma after that. Mutate expected 0 parameters. That's fine. What are we passing it? Passing it stats. All right, we're gonna have to move this down here just so we can get access to it. So we're gonna throw this into the fuzzer. It's kind of gross, but it saves time. Then we're gonna grab hash map and hash set. Okay, and arc mutex. We just need arc. Should just need arc. Okay, and then all of these are going to make public. And command is no longer being used. That's good. Hash set is not being used here. Good. And mutate now takes an argument. So we're going to pass it. We're going to pass mutate, access to the global database. Then what we're going to do is we're going to pick a random input. Let's, what do I want? I want stats equals stats.lock on our app. Time is of the essence now because we have a lot going, so we have to be careful not to take up too much time from other threads. So we're going to do a selection. So we're going to do input cell. Pick an input to use as the basis of this fuzz case. So this is going to go through and do, we need an RNG. I will just make a new one, it's cheap. Create a new RNG. We're doing that outside the lock, so it really doesn't matter what we do. Get access to the global database, pick an input. So we're going to, so in the stats database, we're going to split this again so we can reference it. So we've got the input list, and we basically want to do, we want to select a random input. So we'll do rng.rand, mod that. If that's 0, this will panic, but we make sure it's not 0 on the way up. And we can just Then we can do let mute input is going to be input list of input cell, which is going to contain, basically we want to make sure that this is a vector of fuzzer actions. So this clone, I might have to deref the outside for that, and we do need mutex. 79 input list, of course, stats dot input list. Okay. Expected that, found an arc. Yep, so we're gonna deref that little arcy boy. This should now get us that vec of fuzzer actions. So we basically cloned and we've made a new fuzz input. So we've made a new list of fuzzer actions that we can now mutate. That's ultimately what we're going to return. So if we were to do this, what we'll end up doing is when we do a mutate case, we'll actually just reproduce an existing case that existed before. So basically we have a 1 in 16 chance of trying something new. We have a 15 in 16 chance of grabbing something that previously caused coverage to increase, and then we're gonna feed it back in. We're gonna feed it back in right now. So obviously this is doing nothing too crazy or too fancy, so we want to improve this and actually make mutations do stuff. So to do this, we're gonna go through and we're gonna for in 0.rng.rand mod and oxf make up to 15 modifications, actually up to 16. We're gonna add one. There's never a case where we want to do 0 modifications because we're just gonna reproduce something that we already did. Make up to 16 modifications. And I think what I want to do is I want to go into, I think when we add a new input, we want to, I think I want to have a hash set pub unique actions. Unique action set. This is going to be a hash set of fuzz inputs. No, this is going to be a unique set of fuzzer actions. And then this one is going to be a unique action. And this will just be a vec. This will be the same thing. We're just using the hash set above to dedupe it. A fuzzer, list of all unique fuzzer actions. We're going to move the input list up. Since we have two things that are kind of using this hash set filtering, we should probably make a class that kind of does this behavior for us. But for now, we're just going to do this. Then what I'm going to do is look for any situation where we add to input list.push. Basically any situation where we have a new input. I want to do for action in fuzz input unique actions.push stats.unique actions.insert if unique actions. If this is the first time that we're inserting action into the unique action set, stats.unique actions.push action, and then this will be set. So update the action database with known feasible actions. So basically we're going to keep track of previous operations that we did to calculator, and we're going to keep them in the set. So, and we're only doing that globally. The internal one will not have access to that. So, vec fuzzer action. Yeah, we'll just do a dot iter on this. We'll make a copy. Same down here. Dot iter. Good. Okay, so now we should be keeping track of the action set. That's pretty solid. We're going to get rid of the per second statistic, and we're going to put actions in here. 7 unique actions. That's a more interesting statistic to me right now, so we're just going to put it in here, and I'm running out of space, so I'm replacing the old one. Fuzz cases. Fuzz cases per second we no longer need, and we'll do stats.action. What do we call it? Unique actions. .len. So this will kind of give us the size of the unique action set. Uh-oh. What's going on here? Unwrap failed. 51. Perform actions, failed to perform actions. Okay, something is failing in perform actions. What do we do to generator? So generator now exits on this case. So every case it will enumerate the sub windows. So we'll say if let some if sub windows dot is error return error. Right, that's what we want. And I think I might actually want, I might want to save the progress and return a new vector from here. But let's just return OK quick. It's kind of hacky, and then we'll do sub window let sub windows equals sub windows dot unwrap. Okay, basically our that system did not, or the perform actions was not updated to the new standard that we use. And it looks like we're getting some fuzz cases in. So we've got 173 unique actions. So that's basically all the different buttons and dialogues and things that we've found in the calc application. So as we change the different modes and click different buttons, we record the actions that we've seen. And we're just kind of throwing those in the set. Okay. So that looks pretty good. And now let's get some mutation going. So in mutate, we're going to go up to 16. So make up to 16 minimum of 1. Minimum of 1. Then what we're going to do is we're going to select an input. So we're going to get access to an input. We're going to clone it to make sure we're just going to get an arc to it. Actually, we don't even need to do that. We should be able to do this, and we can do temp input. So we want a random chance of doing a couple different things. So mutation is equal to rng.rand mod 3 match mutation. Let's say the 1 case or the 0th case, we're gonna do this. The 2nd case, we're gonna do this. The 0th case, we're gonna do this. And any other case, we're gonna be like, whoa, unexpected. Okay. input list, self.input list, or stats.input list. So that's fine, blah, blah, blah. Okay, so we do nothing with the temp input. So what we want to do now is we want to find a random location in the current input. So let's start offset is equal to the rng.rand mod input.len. Find the starting offset for our random action. Then we're going to get a length. This is going to be equal to rng.rand mod rng.rand mod 128 plus 1. So basically this is going to be like an exponentially more difficult random, so it will theoretically go up to 128 elements, but in most cases it will stick to like kind of, I think 32 will be the average here. Let's actually drop this down. Let's decrease our corruption a little bit. We're actually going to go pretty low here. Basically, if we want 32, we have to generate it twice, so it makes it exponentially more difficult to get that random number. Then we're going to do input dot rustVec. See, I think there's a way to... I mean, we can just remove them individually for... I would rather remove, like, a whole thing. Splice. Here's a splicing iterator which replaces the specified range in the vector with a given replace with iterator and yields does not need to be the same length. Well, that's fucking gorgeous. Really? Splice to 2. Well, that's... Huh. Okay, so we take a range, we replace self. Wait, does this return something? Okay, it returns U. So we started with 1, 2, 3. We replaced these two elements with 7, 8. We left the 3. And then this is telling us that the things that were removed were a 1 and a 2. Oh. Okay. That is beautiful. Input.splice. Start offset start off. We're gonna do let end is equal to standard compare min between start offset plus. Whoops! Why did I start adding that in the wrong spot? I was like, where did that field go? We're gonna take the start offset. We're gonna add a length, and we're gonna do input.len with that. And we're gonna splice it with an empty iterator. So we're gonna get the smaller between the starting offset and the length and the actual input length. This will give us a good cap to our range, and we're gonna replace it with an iterator that does nothing. Can we do this? So that will... So basically we find a random spot inside of our existing, so 0 case is going to be delete random portion of vector. So get the length of the input vector that we just cloned, the basis, generate an exponentially hard random length up to 32, take the starting offset, add the length to it, and then figure out which one's smaller, that or the input length, such that we don't go out of bounds. Not that it would matter in Rust, but we would get a panic. Then we're going to splice in for the start offset to the end an empty list. So we'll do .iter. There's probably actually just I'll like remove like a range that removes an index. I don't know, whatever. This is fine. Type mismatch, splice, expected reference, found a fuzzer action. Splice. What do you want? You want a range. You operate on a vector. And I mean, I can do the like dot clone. I don't think that's required. Cloned. Okay. I probably had a ref in there. Yeah, it didn't like the reference. It wanted the fuzzer action. Okay. So now that's randomly deleting sections. And now we want to do splice in a random portion from an existing input. So what we're gonna do, so we're gonna splice in a random portion from a random location. So we're gonna do, this is gonna be for the input. So these are the input offsets and things. Then we're going to, we're gonna call this the donor index. This is gonna be the donor input. We're gonna run the exact same logic. We might not even need this mode because we can just have a random chance of having a 0 length from the donor. So I could find and replace, but I think this is faster. Okay. Donor start offset. This is now going to be donor index. Pick a random input. And then this is now the donor input. Find that between that. Then we're going to do input.splice. Imp start offset and imp end. Then we're gonna slice up. I don't think we need this at all, actually. We're gonna splice up the donor input. We're gonna slice it from donor start offset to donor end dot iter dot cloned. Splice in the donor input contents into the input. This should be select a random slice from a random input. Find select a random slice from our current input. Just double checking input list line. Look it up, grab the donor input. That should be solid. We're gonna put a new line there. Okay, start offset. That no longer exists. Honestly, we don't even need to pick between these mutation strategies anymore because there's just a random chance that we delete a section to. Basically, if we were to pick a random selection in the current input and then a donor of 0 length, then we would delete stuff from the current input. 100 start offset. Yup. Okay, and length not found, of course. Donor length here. We're gonna call this donor start. Save some space. Same with the other one up above. Call it start. Input start, that now fits on one line. Input length. Okay, then down here we're gonna do donor start, donor length, donor input length, the actual size of it. Move that out. Input start, donor start. Editor.cloned. Okay. So this is now technically doing coverage feedback with mutations. So will it be any better? Hard to say. The mutation strategy is pretty mild. We might want to add like copy paste a bunch of times. We might want to add that delete one back in. Kind of hard to say. But I don't remember what we hit before for coverage. So what we'll end up doing here is we're going to probably move this to, well, yeah, we're going to implement the different things here. Basically undoing what we did. rng.rand mod 3 match cell 0. Now we're going to have a bunch of reformatting of this code. Kind of sucks. Not too bad, actually. Not too bad. So, can you not find the correct paren there? Okay. 1. I bet we're off. Yeah, we were off by that. 3. This panic unreachable. We're gonna delete a random portion from the inputs. Splice in nothing. Let's do this. Delete this area from the input. This slice from the input. Cool, and then this case is going to be repeat a certain part of the slice many times. So we're gonna do let cell is equal to rng.rand mod input.len. Then we're going to do for this in exponential random up to 128. We're going to do an input.insert cell. Insert, it should take the, yeah, offset in the element. Input cell. So we're basically going to repeat a part of, so we're going to pick a random part of the input, a random action, and then we're going to repeat that action exponentially up to 128 times. Slice. So we're going to probably see a lot more repetition of things. We're going to see situations where like numbers or actions will get spammed a lot more. And it looks like that might be doing good things for our coverage, because our coverage has exceeded the previous run's coverage in half the time. It says slice on 129 in a comment. Oh no. Unusable. Okay, so now we're gonna go up to here. We're gonna put an and with 0. We're gonna put 100% generation on. We're gonna run this for a few minutes. I'm gonna take a quick break. I'm just gonna let this run for a while and see I'm going to see what sort of coverage we get. And then we're going to use this as a baseline to see if the feedback is actually doing anything. In this case, we actually have more coverage already. We might need to... generation is usually better up front, and then mutation gets better. So we might need to like have that change over time to like use more mutation as the input set grows. So I will be back shortly. All right, welcome back. So let's see what we got. Anything new? Yeah, maybe. Actually.
Can you hear them? Listen.
Oh no, maybe not. Not this run. Yet. It's interesting. It looks like we have 3 clusterings here. So let's take a look at what we have. And we're going to make a copy of the fuzz stats. So this is going to be, we're going to call this no mutate.text. Let's take a quick look at these crashes, see if there's anything fancy here. Oh, there's Coco. So we are seeing that now. This is the like very, very harsh corruption bug. If we turn off page sheep, so that 3ADD8, this one as well. Okay, so we know about that. That one we know about. 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 Cool. So all those look good. I'm gonna say crashes. I'm gonna save these away quickly, and then I'm gonna rerun this. I just am curious how quickly we get all those crashes. So specifically the CO, because that took, I think, a couple hours last night to hit. And if we can hit it faster now, that's a sign that we made a better fuzzer, or we improved our fuzzer. If we're hitting a superset of what we hit before in less time, that's an improvement. So whether that's just from threading or whether it's from who knows what, doesn't really matter. We'll take any win here. All right. This looks really good. We actually haven't had any crashes yet. Might just be unlucky. Might just be unlucky. Hard to say. I mean, the other one got 5 unique crashes, so this shows how much variance there might be in the input sequences. So if anything, this is just another good data point to have on hand. We also might want to increase the size of the selection range when we're doing mutations. So we can take a look at that as well. I'm just letting this run for about 2 minutes, just so we can kind of graph it side by side. We can get a decent idea of how much variance there are between fuzz cases and different runs, and this will kind of give us an idea of how much entropy there is in this whole fuzzing loop, and we can see if that's going to be an issue or not. So if we take a look, we're going to copy this. We're going to make this fuzz stats no mutate 2. We're going to modify our graph, which we probably already have open. Then we're going to plot the exact same things in the other files. We call this no mutate 2. So now we have some baselines. So we can see that they performed pretty similar in terms of their coverage, just because the lines are pretty close. Man, I feel like this is just so fuzzy. Let me continue plot line anti-aliasing. I want font anti-aliasing. Can I use it? Line properties. I don't know how to say it. Line thickness. That'll get us kind of in the ballpark. So it's LP. LW. Set style line. And I think you access the style. Line style. So ls gives you the line style. So we'll say ls2. And then we're going to make a new line style. Hopefully this won't take color control. So that's line color. Set style for line to thickness width, maybe. We can take a look at the docs for it. That's better. Let's just set it to like, what's this? I'm gonna make this extreme just to see what it is. Is that the width? And what's the T then? No idea. We can change this to like 1,000 by like 800 is probably better now. We'll set this to 5. We'll set this to 1. That's not gonna automatically set the color, so we'll just leave it. We'll deal with what we got. Okay, so these look pretty comparable. Let's turn on 25% chance of generation, 75% chance of mutation. That might be an issue because I closed a bunch of edge windows. So I don't think that's actually a problem. I was just trying to clean up the 50 billion edge windows that were open on my other monitor. So we're fuzzing, we've got the coverage, we can now plot. We can see like where we're at. And we'll see if we catch up or fall behind. So here it looks like we're playing right in the middle. Kind of in the ballpark. There we repeated a lot of ones, which is good to see. I might want to increase the amount of substitution we do in our replacement to be potentially the whole thing. Because it does look like we're plateauing pretty hard. So one thing that code coverage usually results in is what me and a coworker called Nessies. And that's from the Loch Ness Monster, and it's basically like it's basically when you see like a head peeking up among the ocean's like coverage that's like not increased in a while, and then you see like a Nessie, which is like the little like I don't know. You see like this. It's like the water is kind of like the flat line, and then the Nessie's like, oh, we got all this coverage that like built on itself. Whatever. It's something you kind of see. So like I would say this is like a Nessie, right? You got this like little head peeking out. So how does the plot get rendered? Does it auto update? I can make it auto update, but sometimes it gets flickery, so I'm manually just closing it and reopening it. It takes 2 seconds to plot, so it's not a big deal anyways. Let's see. Looks like we got another little boop on there. So a boop is a small increase in coverage, and a Nessie is like a big increase in coverage. So it looks like it's kind of on par. We could also plot the crash information on there too and see if one's outperforming based on crashes, which is possible. That's an interesting, I don't know if we've seen that address. 3ADD8 we have, okay. So that looks pretty solid, but it looks like it's underperforming what we would get with generation. which means that our mutation is either too low, like the amount of corruption that we're performing is too low. What was that? Oh, I know what this panic is. Oh, interesting. This is in mutate at 110. Yeah, this is, I think, theoretically possible. I'm guessing we're making an input eventually that's 0 length. So we're probably like cutting up an input enough that it converges to 0 length. What we're just gonna say here is, if donor input dot len is equal to 0, continue. And we should just basically put that everywhere that we do these mods. I'm gonna make it a one-liner. If input len, if donor input length. And then, where else do we do mods? Down here, that's fine, that's already been gated. Here we do one on input length. Did I put the one above after as well? Yeah, I did. Okay, if the input length is 0, continue. If the input length is 0, continue. Oh, you know what? Our inputs are going to converge to 0 size. And the reason for that is we don't have something that just guarantees an insertion into a vector. So we want to do that as well. So that's probably why we're hitting that 0 size. It's probably why our fuzz cases are yielding pretty shitty results. So that's going to delete. We'll gate this one. I think we should be better on panics now. Okay, and then we're going to add, I think here, there might be a way to insert. I want to insert at a certain location. Append. Yup. Extend from slice. Push. Swap, remove, truncate, split off. I don't see a way for me to insert into the middle, which kind of sucks. But we're just going to do this. We're going to make a third option. Insert random slice into the vector. Select in the current, select in the donor, and then we're just going to do input is equal to input is equal to 0 dot dot or actually 0 dot dot input start dot iter dot chain with donor input donor start to the donor end. And in this case, we don't need to actually slice input. We'll just input index. So we're going to pick a random index, select a random index from our current input. We're going to pick a donor slice. Then we're going to, from here to the input index, we're going to iterate through those elements. Then we're going to go through the donor input from the start and end of what we're donating, or we're taking from the donor input. We'll iter these. We'll do another chain on. This will be input that.iter. This will be input imp index. So basically, we're going to go from 0 to the index, iterate through those. We're going to chain that with the donor input from the start to the end of the donor input, and then we're going to chain that with from the input index to the end. So we're inserting a random donated slice from somewhere into the middle of this buffer. And we're gonna do this, we're gonna copy this into new imp is gonna be a vec of fuzzer actions. And then we'll collect this into the vector. So we'll collapse the iterator into the vector. And then we're gonna replace this input with new imp. So we're gonna swap that in its place. So splice in donor slice into the middle into input index in the input. Replace the input with this newly created input. Cannot be made from an iterator of that. We'll just do I got cloned and we're done. And we just got to update this to now go to 4. So now we're going to have some splicing into inputs from existing ones. I think this will be a huge improvement from what we had. Guess we're going to see. You don't know until you know, you know? Case is coming in. We could also decrease the fuzz case time or increase the fuzz case time. Both of them could have dramatically impactful impacts to the fuzzer. Looks like we got a big Nessie there. Looks like we're kind of on track with the others. Looks like we got another big Nessie. I guess not too big. So we're still kind of on par with the generators, which makes sense. I mean, we're pretty much limited based on what the generators are capable of doing. I want to see it outperform really bad. In this case, it's just a really hard, it's really hard to make meaningful mutations. So we're outperforming 1. Until it outperforms by a significant margin or maintains outperforming, I'm not going to say that the results are conclusive. This is well within the noise floor of the mutation and generation. There's also just not much coverage to be had in this application. So this could be fuzzing better. This could be like creating a higher chance of crashes. But there's a chance that it's not actually causing more coverage because there might just not be much more coverage. So we might be kind of hitting almost all of the things that we can do in calc. We actually just got a little Nessie there. We're now on par with that one. That looks good. And let's see if that will feed back onto itself as well. So what's really cool about fuzzers is they get better over time. Like this fuzzer is starting off pretty mediocre. Obviously, this is now a really good harness. This is now a really good environment to develop fuzzers in. It looks like we are starting to outperform now. We'll see if we can maintain that. We've got we can run for another 3 minutes until we kind of run out of data, but it looks like that plateaued pretty hard. I think the odds that we hit a big jump in here again, and we never saw it in this one, probably shows that feedback is actually working. We're getting small increases there. We're about to actually collide with this line. So the next thing we will do is we're going to start playing around with some of these parameters. I just want to let this run. I want to see if I can get some decent results out of this. I think I might pull up. I might try and get a VM set up. Let's so we got a slight increase there. It looks like we're getting pretty slow gains. We got a crash, 1C484. That's probably related. Yeah, we've only hit 3 neat crashes so far. We're gonna want to probably dump out some of the inputs and manually look at them visually to see how they look. If we see zeroed out inputs, if we see like really empty inputs, or that the calculators aren't doing much. In fact, I think I saw a couple of those that like weren't doing all too much. There's a chance that we might need to increase the time or change some of our mutation strategies to not be as hostile. We might be removing too much. We might have too high of a chance of removing entries from the vector, which would then cause us to have fuzz cases that are effectively doing nothing. So let's see where we're at. Yeah, it looks like we're basically on par. Not happy with that. Let's make it better. 8623. Okay, that wasn't too big. Not a big deal. All right. So we can rename this. We're going to call this fuzz stats first mutate. So this is kind of our first mutation strategy. And we're just going to add this to the graph. Now that's in there. We're going to turn the key back on. We're going to do set key left. Actually, bottom. So now we have a key so we can see what the different colors are from. But yeah, all of these are basically the same. Nothing too crazy, nothing fancy here. Disappointing. Let's, we're also optimizing against coverage, which might not necessarily be the best metric for a calculator, which is going to have a lot of common paths with a bunch of different states and whatever. Okay, so we're going to want to flush out some of these inputs so we can visibly look at the inputs. So let's write some of these out. And we might want to increase the fuzz case. We might want to decrease or increase the fuzz case length. It's really hard to say. Always kind of a difficult problem. Like if you reduce the fuzz case time by 4x, but you only get a 2x reduction in coverage per fuzz case, you might actually be coming out ahead. So just a bunch of things that you kind of have to play around with and fiddle with until you get a really good environment. So here, when we're adding this to the input list, we're also going to make a file. I think there's a way in Rust to get a hash. That feeds it into a hasher, hash slice. So we know that the fuzz input should be hashable. That's going to mutate into an existing hasher. Make a hasher, get the default hasher, write that stuff in there, finish it. Okay. So we're going to hash the input when we push it here. We're going to make a new default hasher. Means we're going to have to bring in these. Not a big deal. Get the default hasher. We're going to do hasher dot we're going to do fuzz input dot hash mute hasher question mark maybe. Hash is this fuzz hasher finish. Okay, use standard hash. Beautiful. So we'll see what that hash looks like pretty quickly. I think it's probably like a 128-bit thing, maybe. Why are we not seeing that? How are we not seeing that print? Oh, this is on crashes. We still want it there. record input fuzz input.clone. Okay. Then we're gonna we're gonna make function record input. Whoop. Record input fuzz input clone input list dot push. Put it in here. We're gonna hash it. We're gonna make a new file. Create format inputs slash XO32X. I'm gonna guess it's 128-bit. Finish. That's at U64. Ooh, okay. Make a new input. We're gonna do standard fs, create dir inputs. We're just gonna ignore whether that succeeds. This one will accept on hasher.finish .unwrap. Let's file equals this. Actually, we can do standard fs write, and then we're gonna write format debug format of the fuzz input. Expect failed to save input to disk. And that looks good. Here we're gonna do fuzz input. This is just gonna be fuzz input. Let that equals that. Fuzz input not found in the scope. What do we call it? Didn't we call it fuzz input?
We're gonna sketch one song.
Yeah, we did. We need to make it pub. Okay, 24 unexpected token. Unexpected token. Format, comma. That. Okay. So this will now create an inputs folder. The inputs will contain all the different inputs. And the inputs will be a list of the commands that they're doing. This will just give a rough idea. If we see these decreasing and decreasing and decreasing over time, it's probably safe to say that we're deleting too much from inputs. If they're growing, we're probably adding too much to inputs. They look pretty healthy. We do have a 1K. That's not great. So we could put a little priority. We could put a slight priority on so delete a random portion. We can increase. We're gonna put this up to 8, and we're gonna say 3 to 7 or 3 to 8. We'll go into there. Really? Is that actually experimental? Yeah, is inclusive range experimental? No. Okay, so we can do that. So now we've increased the frequency that we're doing insertions. We're probably gonna see much larger inputs now. If we see too much input explosion, we can always truncate them down. Like basically when it feeds them through, it'll report how many were actually fed through. So there are a bunch of things that we could potentially do there. All right, plot. Where are we at? We're on par. Looking fine. Okay, we're falling behind. Looks like we jumped up a bit. Sometimes it's hard to say, like something's some things turn into much better situations. Any bugs so far? Yes, we have actually a decent amount of bugs. So we've got like 6 null derefs, stack overflow, 1 or 2 use after freeze, and uninitialized memory uses. Or like maybe a double free on one of them. Which is pretty crazy because we're this fuzzing is unique, to say the least. It's a unique way of doing fuzzing, that's for sure. But hey, if you're looking to fuzz your application to see whether or not a user could cause a crash via inputs, this might be a good way to find it. Like if user interaction bugs and more of a testing thing. So that, my friend, is a Nessie right there. Love it. And if you'll notice the I guess the no mutate had a decent bump. I don't know, that's like one of the biggest jumps we've ever seen so far. It's hard to say if that's attributable to coverage or not. If we like look in here, this one's pretty big. It looks like it's almost twice the size of almost all the other ones, which is kind of cool. Oops. We just got another crash that came in, 1C34. I think we know that one. That one is related to kind of the others. So, just got that plotting out. Looks good. 8444. Bumping up there. Will you implement right clicks? Yeah, eventually. So, right now I'm just trying to get the coverage and feedback and mutation working. Everything's looking pretty good here. The next stage will be to find better ways to interact with calculators, so we could maybe play with drop downs more frequently. We could maybe spend less time generating something, more time generating something else. There are just a lot of different things that we could potentially do to make it better. It's hard to say what all we'll add, but we're gonna keep adding stuff. So I remember one target I fuzzed. I remember having very similar results early, where we had like 8,000 blocks of coverage early on, and it was really disheartening because 8,000 usually is too small to have exploitable bugs. Obviously you'll have bugs, but exploitable bugs is a much different category. But I think by the end of the project we were up to like 107,000. So it's important to note that, and the 107,000, like we would hit like 40,000 within a minute of running the fuzzer. So fuzzers get better over time. I would not be surprised if we could get this to, if we could get this maybe up to like 15K within the first few minutes of fuzzing. Whereas we've never even crossed the 10K boundary, and I bet a couple hours in the future, couple days of work in the future, we'll probably be massively outperforming, and we'll be seeing numbers that we never thought we'd see before. So let's play around with calc, and let's see if this coverage lines up with what we would expect. So we're gonna use normal mesas for this. We're just gonna run the exact same command, and this is gonna pull up calc in an interactive mode: get status, get reset, hard. And we're just gonna play around with it, and we're gonna see what we think we should get for coverage. So this only prints every 5 seconds. So this is saying 2,600 unique coverage entries. So just starting calculator gets us to 2,600. I'm going to make a quick modification to libs debugger source debuggers. We're going to set this to a 1, and now we're going to print more often. So we see just starting calculator gives us about 2,600. Switching modes gets us another like 300, switching those modes. Doing some operations, randomly clicking stuff, that gets us to like 3,500. So Like, just this random clicking is very far from what we're hitting, right? We're at, like, half of the coverage we're getting, and I'm just, like, clicking around on random shit. Pulling in the history, that seemed to do a bunch. Some of these menus, copying, pasting, switching modes to all the different ones. I mean, this is actually quite impressive how we're hitting 8K almost instantly when I'm struggling to get back up to those counts. So I think exiting calculator actually gives a lot of coverage. Maybe help, maybe. Nope, that doesn't really do anything. Copy paste data set. Closing it, I'm guessing, will get us a bit. No. So it's definitely exercising a lot more of calculator than I would expect. So let's see, we can sync this out and we can look at it in IDA. We could try to figure out how much coverage or like what we're missing. We can get a kind of a ballpark on if there's anything that looks like we're not seeing. So trying to think of the best approach here. Let's check in on this guy. How's he doing? Let's see if he found anything. So this has been fuzzing for much longer than what we've been working with. So this might be like leagues ahead. I'm just gonna hard turn that off. I'm gonna pull this up. We're gonna see what we have. I think that's it. That hasn't generated a new crash in 3 hours. So I think that's pretty much dead. That's donezo. So we don't necessarily know how the feedback will perform. Let's make a couple modifications here. So one thing that we do is we do this 32. Let's do input.len. So we're going to give an exponential chance of selecting up to the length of the input. Which I think will potentially stress a little bit more here. It's hard to say. We're just making guesses. Here we're going to do input length. Here we're going to do donor input length. Okay. 32, 128, 64. I don't think we have anything really hard-coded anymore. And let's 0 dot equals dot, oops. Dot equals, which one had it? This one. We're gonna drop this back down to a 4. We're gonna do uniform distributions, and then we're gonna change up to let's do 3F. Let's increase the amount of modifications that we're doing. So we're doing heavier mutations. We're grabbing larger parts of inputs. We're doing larger replacements. Let's see what this does. Okay, I think that looks pretty standard. Nothing out of the ordinary there. Crashes look fine. Kind of on par with everything. It's on par. What did we lose? Some DLL got loaded. That confused us. Some DLL got unloaded that we, for some reason, did not see the load event for. Is effectively what that means. Hard to say if that's a bug in my stuff or just a really weird interaction issue. Yep, this is all Rust. Okay, so this is looking okay. I actually think that the thing that we should do more... Honestly, this is actually looking pretty bad. And this is something that can happen with more corruption, is you, like, kind of increase your variance. You have, like... When you get coverage increases, they're usually more significant, but you get fewer of them. In this case, I think this is. I think it's actually. I think I normally log scale. I think I normally do a log scale X, not a log scale Y. Everyone fine with saying that we made the fuzzer worse by tuning those parameters? Isn't that crazy? All we did is we changed like some of the slicing and some of the sizing of things, and we dramatically reduced the amount of coverage we're getting. And that's why tuning fuzzers is so important. It's so important to get in there and make changes, because this is what happens. It's so easy to ruin a fuzzer, and we just got an increase, and that increase is kind of a joke. Now, there's a chance that this like increase, and really paid off. I doubt it. And even if this does pay off, even if this did like somehow go crazy, I think we can outperform at all tiers with a good mutator. Let's take another look. We got another boop. Yeah, it's underperforming by a pretty significant amount, actually. It's underperforming by almost 1,000. So let me switch to log scale X, which is what I'm used to. I don't know why I was using a log scale Y. This is much better. So now we're seeing on the absolute coverage on this scale, and now it's really shown a little bit more of a difference. We can see that this is massively underperforming. It's much worse. And then we have fuzz cases logarithmically, because over time your fuzz cases get less and less impactful. So I found that log scale X graphs with coverage on the y-axis is the best way of plotting fuzzing. You get kind of the best visibility into what is going on. So this looks definitely worse. So now here's kind of the interesting flip of, if by changing those things we could make it significantly worse, can we change something to make it significantly better? Let's give it a shot. So let's drop this number down back to an F. This will give us kind of another comparison point to see how this performs. So we left in the full input length selection, but now we're doing fewer mutations, so we can see how this behaves. That actually got a new crash that we haven't seen. It looks related to the others because it's nearby, so I don't think it's a crash we have never seen. It's just a new crash for these runs. Looks like we're underperforming right now. Yeah, this looks stuck. Ooh. Okay, a little Nessie. But it still looks like it's underperforming. There's a chance it could Nessie again. We'll give it like 30 more seconds to prove itself. But so far it looks like a dud. That looks pretty healthy actually right there. This is a pretty like common pattern you see, like a double bump when you're doing coverage. This actually looks really good because it's kind of like a consistent linear growth pattern. That's something I really like to see. This is actually a really healthy looking curve right now, to be honest. There's a chance that this might actually be a pretty good setup. Hard to say.
So as soon as it stops raining.
But I've got a couple ideas. Looks like it's falling off. Like, if it kept up that trend, that was going to be looking real good. But, yeah, it looks like that's kind of tapped out. Is fuzzing strictly to find a vulnerability in an app? Usually just to find bugs. Vulnerabilities are probably what most fuzzers are for. So we're going to drop this down to a 3 to dramatically reduce the amount of mutation that we're doing. But yeah, you can use fuzzing for anything. You can use it to test your app. You can use it to test your website. You can use it to test interactions or see weird behaviors. It's really just trying to stress your application or whatever you developed. And that has a lot of cool results. So this looks like it's massively underperforming. This looks really bad. But it's hard to say. Sometimes it's just hard to say until you see things run for a bit longer. But I'm going to call it, I'm going to say that's trash. You know, that was pretty good there. Okay, that was good too. So basically when you decrease the amount of mutation you do, you increase the amount of interestingness from the coverage cases that you took before. So if you take an input that previously was known to generate an interesting block of coverage, it hit new code that has never been seen before, but if you mutate it too heavily, you no longer will probably hit that unique location anymore. And if you get to that point, you probably ruined the input that previously recorded as this is a good input, and you've just clobbered over it. So you have to be very tasteful with the amount of corruption and mutation that you do. 1, 2, 3, 4, 5, 6, 7, 8. Do we have more crashes than we've had before? I think we do. This is like getting up there. I have an idea that would hopefully make this this a lot better. Yeah, it looks like it's kind of plateauing. Let's take a look at these crashes. Let's see if anything new came in. Null DRF keypad inputs. Null DRF keypad inputs. Keypad inputs. That is, we know about this one. This is the uninitialized use. Keypad inputs. Guessing this is keypad inputs. Guessing this one is a null. Another set template. Template arg changed. Yep. Okay. All right. So those look solid. What I'm going to do is I'm going to change this to 32. I'm going to change this to F. Actually, I'm going to change this to 3F. I'm going to mark this one. Random slice into the vector. Delete a random portion. Wait, are we not using? Are we not? Are we not using? No. We implemented unique actions and then we never used it, did we? Son of a bitch. All right. All right. So we're gonna do 4 dot dot. This should be equal 31. Mod 32. Yep, equal to 31. We're gonna get rand action is equal to unique actions. Actually, stats.unique actions at rng.rand mod stats.unique actions. We're gonna say if stats.unique actions.len is equal to 0, continue. So we're gonna get a random action. Get a random action. So this database is really dense, this unique actions database. So we want a pretty good chance of generating these random actions. This is only going to create, this is like a bit flip. So now what we're going to do is we're going to pick a random location. We're going to do input.insert rng.rand mod input.len rand action. Add the action to the input. Okay, and this will be if input.len is equal to 0. Why not use another shell other than command? I like command. I don't think it's too bad. It has limitations, but it's good enough. I don't like having a really customized dev environment because you end up not being able to work on other machines other than ones you spend hours setting up. So I'm a pretty big fan of that. I can't mod this with len. So it's really just to decrease the amount of like specialization of my dev environment. Okay, so now we're generating a lot of these random actions. I have no idea how this will perform. It's really hard to say. Might be terrible, might be good. But sometimes all that matters is just different. We did get a crash pretty early on there. Compared to before, we're up to 2 crashes, which is nice. 6680. That's looking good. Graph's not looking great. Hard to say. Are these genuine crashes or because the program gets overloaded? Doesn't matter. They're all crashes to me. If the program gets overloaded and crashes, that's just as much of a crash. Especially with the timing on these fuzz cases. Like if we were running these fuzz cases for days, then yeah, it's like not as important. But these are what do I have? I think 7-second fuzz cases here. Let's take a look at our inputs going in here. See if the inputs look gross. No, looks like input sizes look sane. Everything looks pretty solid here. Huh. Not doing as well. I think maybe these slices are just too big. We're gonna drop these down actually to like relatively small ones. We're gonna go down to 16 for swaps. 16. Well, that one made no sense. That one made no sense. Length. Let's put that at 16. Donor length, input length 16. Looks good, not gonna fit. This is up to 16. Put that at 256. I think that's fair. Actually, probably 64. Donor length up to 16. Looks good. 31. We're gonna drop this down to 16. We're gonna keep that at 32, but we're gonna up the frequency of corruptions. Is a blue screen of death possible with this? Absolutely. I'm actually kind of surprised we haven't seen one yet. And yep, I normally stream on Science and Technology, but just chatting seems to get a little bit more traction, seems to make a little bit more sense. Science and Technology just seems to always like end up at the bottom, like the dumpster of categories. So like people will find this through the just chatting section, but no one looks at Science and Technology because it's like just not really a category that people use. So looks like this is kind of back to where we were. We kind of reset it to where it was. Kind of on par with the previous fuzzers that we had. Crashes look good. That looks pretty solid. 78. 7841. Haven't broken that 8K barrier yet, and these are at like 8,500. Okay, let's change some tunables. We're gonna drop this down to F, and we're gonna drop this down to 8. It's weird how visibly you can't really tell if it's better or worse, but it's pretty obvious based on the coverage numbers, like if it's getting more coverage. It's pretty bizarre, actually. So that's looking on par. Don't really have data yet. 79. That might be a completely new crash. 1699E crashes. Yeah, this is a crash we've never seen this before, ever. So I don't know if that's because we changed it to be better, or because like coverage looks like it's worse, but maybe it's stressing state better than before. That's hard to say. And that 1.6 is not in the ballpark of these other ranges, so it might be a completely different surface that we haven't seen yet, which would be really cool. Inputs here. One 699E. Yeah, we're really falling behind here on the plot. There we just got a little bump. We got a new one. We got a 1686. Okay. I think this is better. It might not be better for coverage, but we just got 2 crashes we've never had before. Like they were nothing. Does CPU usage get high? Not really for this. I'm only running 4 calcs. It's probably running at like... CPU usage is probably like... I don't know. We can check. Probably pretty middle of the road. Yeah, like 80%. Yeah. Actually, probably like 70%. Looks like it spikes sometimes. So this is in a really unique state. We're getting crashes that we've never seen before, which is always interesting, of like why is that happening. This is a really like normal looking Nessie here. 8304, we just got a big Nessie. It's huge. A325, 26. We got another new crash we haven't seen before. Right? 16. Oh no. Yeah, these are the same. Are they? We might have gotten a new crash in there with that Nessie. I'm not sure. It's hard to say. What are the X and Y on the graph? So the X-axis is the number of fuzz cases that have been performed. Basically, the number of times we've opened calculator, generated random inputs for it, and then it's exited or crashed. The Y-axis is the number of unique coverage events. So the number of like unique parts of code that we've seen executed during the fuzz case. And basically what we're looking for is we want, like, the higher up this line is, the more code in calc we're exercising, which would indicate that we're probably stressing more rare parts of code. We just got another Nessie in there, which is good. This is looking solid. So we could add keyboard inputs. That would be a good thing to add. We could add right clicks, which I actually don't think there's anything that can be right clicked, but keyboard would definitely help. Typing numbers and typing like digits would be, or like the decimal point would be useful for like filling in these things, because we almost never exercise that code. It looks like sometimes we do get stuck on that like fuel economy sort of things. Technically, I guess we're hitting buttons that maybe we're not able to hit because they're like grayed out, but Okay, we're about to get a new bar on our graph on the x-axis. So far, this is probably the one I'm happiest with. It generated 6 unique crashes, up to 7 unique crashes now, which is pretty awesome to see. Coverage is looking healthy. But yeah, we got 2 new crashes we've never seen. We have 7 unique crashes. We've been running for 5 minutes, and we basically have generated almost every crash we know of in Windbag. You find bugs for money or just for fun? This is just for fun. There's no money in these bugs. These bugs are worthless. Hence why we're streaming. So it looks like we've stagnated at 84.95. We do know that we can go higher there. 85.33, that's a good boop. Up to 100 inputs in the input database now. Pretty healthy. Looks like we're saving about one input every 2 fuzz cases, which means we're still getting some decent growth, but that's starting to really fall off. 86.13, that's good. Like, this zigzag pattern is gorgeous. Okay. Just watching it for a little bit longer. I want to see if we get one more Nessie. I want to see if we can get into a coverage territory we've never seen before. And we might not. So we might be stuck in like a little trench here. So I think what we're gonna do is we're gonna try and get this set up on a server, get more fuzz cases through it. Because right now we're only running 4 instances. I want to run more. So 86.49. Okay. Looks pretty solid. Yeah, it's not really moving around much anymore. But that looks pretty healthy. It looks like we're getting up to the same points. We've hit 8 unique bugs now, which is almost every single one we have. So that's 4, 5, 6, 7, 8, 9, 10. So we have 10 bugs total that we've ever found. And this found 8 of them within 8 minutes. So that's pretty good. And we are still getting small Nessies here and there, which is nice to see. 86.82. We're about to cross a point we've never seen before. Not that that really matters. We are 1 order of magnitude kind of behind schedule. Or I guess not 1 order of magnitude. We are... Yeah, we're about like 4 times longer execution than I think our others, or 2 times longer. I don't know. But yeah, we're kind of plateaued at the same spot. I just want to see if we can cross kind of that threshold. We're going to throw this up on a server and try and get more fuzz cases. 86.82 seems to be our cap. I don't think we've ever seen 9K. So 9K would be big. 10K is going to be like a really exciting number to hit. I bet we'll eventually hit it. Maybe? It's hard to say. There might be some really weird interactions between like keyboard and mouse use, so I think we will want to get some keyboard usage in there. And I guess we'll just throw a random keyboard event at a random GUI element, I guess. Kind of. Okay. So that looks pretty solid. I'm going to call it there. We're going to take a look at these crashes we've never seen before. Null deref and delete history. This is a vector null drfin get history. I'm guessing there's probably a way to delete that history. So I'm just gonna grab kind of all these crashes, put them in the crashes folder so we have them. They're the same name, we don't care. And what I really care about is, I think, which one is the CO one? 3dB? Nope. 3A? Yeah, 3A. So the one that says add is the one that has CO. So that is the uninitialized memory use. So what we can do is, I just want to see how quickly that shows up. That is the one that I care about the most right now. Any other programs we may test in the future? Not sure, hard to say. Probably. I don't know what they will be, but we'll definitely be fuzzing more stuff. Okay, that looks good. 1, 2, 3, 4. Little nully boy. Another nully boy. All right, let's just get this up on a server. Okay, and sudo su. So let's get apt install virt manager and Debian virt manager. What do I need for getting KVM set up? Probably just QEMU-KVM, I think. Fuck it. We'll install these and we'll install virt manager. This looks like a hacking sequence for a bad movie. Yeah. Yeah, that's the beauty of GUI fuzzing. We'll just upgrade this server quick. I think this is on a platter, so it's a little slow. Oh, come on. Yeah, this is definitely on a platter. What disk do I have this on? DFH. Oh, it's on the 10 tera platter. Okay. Well, we got storage space at least. I guess while this is running, we could maybe look into getting key presses going. Actually, I want to play around with one parameter in the generator. So the generator generates sequences, and the sequences are used a lot. So we have... Let's increase the menu item click chance. And let's increase the chance of closing the application. It's hard to say. Is it helping or hurting? Looks like hurting. Looks like we're not able to type nearly as much. Yeah, that seems to be a pretty big loss there. Maybe we want to go the other way. Yeah, these are... Look at this. This is terrible. Wow, wow, wow. It's creeping up. Sometimes you have those sneaky fuzzers that like Nessie their way to the top. But we're gonna put this up. We're gonna increase the... We're gonna decrease the chance. I think we were at 3F before. We were at 1F before. We're gonna put it to FF. So we're gonna dramatically decrease the chance that we select a menu item. So we're gonna spend a lot more time clicking on buttons rather than clicking on menus. And we're gonna go back up to here, and we're gonna change this to just a 4. We're gonna make this uniform, which I think is gonna be better. And then we're gonna put this to slightly higher modifications. Run machine learning to adjust RNG. Yeah. I mean, that's effectively what we're doing. God, that graph actually looked pretty good. So this coverage looks trash. That's like off the charts bad. I guess it's probably never changed the mode. What if our initial numbers were like the best ones we had? We could go back to smaller mutations. Only up to 4 mutations. See what happens here. Killing us. Oh? Ah? Yeah, it's trash. I mean, maybe it's really good for crashes, but it's really bad for coverage. Hard to say. Put that to F. Put that to 8. Those are kind of known goods. We're going to test. Got to be careful not to change too many variables between tests. I don't know what I just... apparently mousing over those really made it unhappy. Unreachable. Oh yeah, because we changed that to a fixed. Okay, that's fine. Not a big deal. Mutate, go through. Looking good. Yeah, the coverage is... Coverage is so much worse. So let's kill that. There's also a chance that it's still really good. Maybe we're not exiting the application as often. So we're gonna go up to here. Gonna drop this to 3F. Clicks look good. Chance of randomly clicking the application. We're gonna drop this down a little bit. Good growth. 60, 62, 66. This is an up and comer. 7207. That one shot up there. Now it's gonna stall. Guarantee it. Gonna give me the runaround. Get me all excited. Making me think it was a good fuzz case. Let's do 7494. That's solid. Doesn't look terrible. 75. No crashes though. It's been a minute, no crashes. doesn't look great. $76.16, $76.20. I don't know. It looks worse. Looks worse. What if we just like never close the application? I'm curious how much the application closing is helping or hurting us. This means we're basically always going to hit our timeouts. But we'll also never hit like a lot of cleanup code. The cleanup code of closing calc might actually be like the 2000. Like right now we could be at 8500 equivalent coverage, but we didn't close it, so we haven't seen like the 2000 from closing calculator and all the destructors for that. Kind of hard to say. We're gonna want to start getting some human eyes on this and graphing the information that we have. See if we can find out kind of strengths and weaknesses of the different fuzzing algorithms here. We're not getting any crashes here. This looks terrible for crashes. So here's something we can try. We can go to... that's 4096. Let's go to this. We're going to drop this down to an F. Then we're going to go into libs source debugger, libs debugger source debugger. Somewhere we have like a 7. We're going to drop this down to a 3. Somewhere we have a couple thousands. I'm going to see if we can drop this to 750. Have another one here. Oh, that one didn't matter. It was just that one. And then we have a couple sleeps. Control C handler. Here we have a sleep on that's waiting for a renderer. Let's see if we need that. Did we? Let's put it at 50. It's not doing anything. Is that 1 second the magic number? Without that, nothing works. That's a magic number. Now we're doing more fuzz cases, so on this axis, it'll probably look like it's underperforming, but on the time domain, it might actually be performing better. Oh, platters are so slow. How did the world exist before solid state drives? Okay, so we're gonna call that one worse. Okay, we're gonna switch over. We're gonna set. Let's actually see how much the sleep in here mattered. Let's put it to 500. Looks okay. Nothing out of the ordinary. Nothing terribly good or terribly bad. Looks mediocre. Looks very mediocre. Looks like it's almost hurting it. So let's switch over to let's get rid of this sleep. See what happens. Really? We got nothing? Nothing crazy on crashes. Just got 2 crashes. A 3D 51A. Is that one new? .3D 51A. Nope, we've seen that before. Okay, I think that's worse. What do we have this at? Like 250? 250 is pretty solid. Gonna put this back up to F's. Gonna put this at 1F, which seems to be a magic number. What else are we gonna do? Let's increase our chance of mutating over generating as well. We haven't played with that parameter in a while. Okay, good. I think we're gonna increase the fuzz time. I think we put it to 3. I'm gonna put it to 15 seconds per fuzz case now. So this might be better for crashes because it will just exercise much deeper states. It'll just like spew a lot more crap in there, hit more stuff. We have less, we're spending less time. This will look like it's overperforming because the fuzz cases are longer. So there's more getting done in a single fuzz case. But this just lets it run longer. It decreases the application startup overhead. The more fuzzing you can get in one fuzz case, the better, because it means you're not restarting the application, waiting for those long startup times. Looks like some of those got stuck. So, yeah, if we look at this, it'll look like it's actually just kind of on par with everything. What do we want to do here? I think we want to increase. Let's go up to 25 seconds per fuzz case. And we're going to bring the 1,000. We're going to put this to 1,500, give a little bit more time for the application to start up. And then the sleep in here, we're going to change to an rng.rand mod 500. So we have a chance of doing some like really fast interactions there. Having a fixed sleep is pretty dangerous when fuzzing, because you might end up in a situation where you do an operation at the same speed every time and you don't stress like switching speeds or like jitter, weird interactions like that. So I have a couple fuzz cases. You got crashes right away, which is always a good sign. We got ADD. That's the good one. So that one came up really fast. We got a 686, which, have we seen a 686 before? No. So we got a new crash. So we're hitting new crashes. We're up to 5 crashes now. 6 crashes, 3 unique, 7,700 coverage. That looks pretty good. I think this is the best one we've done yet. What's fuzzing? Ooh. Basically, fuzzing is generating like random inputs and events to an application. Usually it's more done on like the file format of like you generate a file with random contents, or you corrupt contents of like a PDF. You open it up in a parser or something that uses it, and then you try to see if the application misbehaves when that occurs. And the goal is usually to look for bugs. Bugs usually mean security errors, and security errors usually mean exploits or vulnerabilities or things that you need to fix or exploit depending on what side you're on. So basically we're randomly clicking and inputting and doing things to calculator, and we're looking for like really weird exceptional situations, and we're basically looking for crashes. So the 686 was new by a decent margin. We've never seen anything in that area, I don't think. 1C 484. I think we do know of the 1Cs. 1C 484 is known, but the 686 is. Oh, there was a 686 in there. Never mind, it's not new. So, yeah, we haven't found any new crashes with this. We're up to 8,000, solid, looking good, on par with kind of all the generation strategies. We can make a quick tune. We can see if we're better off with generation or a mutation. So where we have that F here, we can change this down to a 1. Now we have a 50-50 chance of generating a whole new input case and exploring the application versus going through and mutating. It's always hard to tell like what the best values for these are, but you pretty quickly hone in on some that, or at least you learn the impact of them. And when you learn the impact that certain things have, you can kind of make better decisions of how to tune your fuzzer going forward and what changes to make. So all those just timed out. No crashes yet. Obviously, that's going to look dense. I don't know. I think the mutations are helping us, not hurting us. So I think we want more mutations. $7,200, that's good. Just on par with everything else, but fewer crashes. Actually, no crashes. I'm gonna switch back over to using more mutation. We're gonna go really heavy on mutation over generation. How does this work? Do you send click events directly to the calc GUI? Yes. So we enumerate kind of all the buttons and things that are present on the GUI at a given time, and we send random inputs to it. That's basically it. We actually developed that at the start of this stream. So if you are interested in how we did that and kind of what went into that, we did that all on stream today. Ooh, that coverage looks real good. 4 inputs, 6608. That's dense. How do you know if a crash is promising? Lots of experience, to be honest. Just like having a good hunch, knowing roughly what an exploitable bug looks like, what like bad and good properties are. Can you make an algorithm to automatically change these parameters and optimize for number of crashes? Yep, absolutely. That's pretty standard in fuzzing. We're just kind of not at that point. Haven't developed to that part yet. Rust. Yep, this is all on Rust. Everything here is Rust, except calc. Calc is not Rust. So this is at 7015, which ain't great. I don't know. What do we want? Do we want this at F? Is F the magic number for that one? And then up here, this one, 750 to put an average at, what is that, 475? Or not, 375? Kind of up that timeout a bit more. And I think maybe like 10-second fuzz cases. I think these might just be too long. Kind of unnecessarily long. Why target old calculator? New one's open source. Because the new one is not as cool. The new one doesn't have the legacy and the impact of the old one. The old one is the one we know and love. Okay, that coverage looks phenomenal. What? We've never seen that before. It could just be a complete fluke. Could be an absolute fluke. But that looks really good. I think it's a fluke. Ooh, 3 3db43. I think we've seen that before. Yeah, we have. Okay. Yeah, it's just gonna flatten out and meet up with all the other friends. That was just a pretty incredible fluke at the start. Crashes look good here. Unique crashes are mediocre. Coverage represents the amount of unique blocks that we've seen in the application. So it's kind of tracking the different code that is executed in calc while we've been fuzzing it. So it's telling us like how much of the code we have exercised with our fuzzer. So some of these are stuck. And I don't know why they get stuck. But stuck fuzz cases are dead fuzz cases. I wonder if those had zero length inputs. Maybe that's an issue we're having. Good little Nessie there. We're just kind of on par with the other ones. That's fine. I will take par. Seems like it's been hard to kind of match that anyways. Okay. Okay. Come on. I'm not going to be able to type in here. I'm not going to be able to do vert manager. I'm going to reboot this box quick. Why do you have Edge installed? Because it comes by default. Standard. Okay, that's looking kind of flatlined. If we can't outperform a faster fuzz case, then we probably want to be doing faster fuzz cases. I think we set it to 25. Let's drop it down to 8. See what happens. That looks good. Fast fuzz cases, good coverage on fast fuzz cases. Fantastic. Love seeing that. No crashes yet. Don't like seeing that. Seems to be on par. Little Nessie. Got a crash. 1C184, we've seen that. This looks pretty solid. $71.85, 72. Okay. 75, big Nessie. Okay. 76. Looks good. $76.18. $76.30. Okay, that looks fine. Nothing too crazy. 2 unique crashes. We're getting a lot of crashes, not too many unique crashes. Coverage just isn't doing too much, I don't think, in this target. Mainly because there's just not too much more to explore. Well, there's a big Nessie. It's an 8063. Yeah, no luck here. I mean, we're in the 80s. That's solid. 8095. Good to see. Always like to see 8095. All right, we're gonna get this up on the server. Let's go. It's time. It's time. And what's a good VNC server for Linux? X11 VNC, is that the one? I think X11 VNC is the one I'm used to using. Doesn't mean it's good, just mean it exists. Link to your music playlist. This is just the continuous stream that's always up on YouTube. It's the lo-fi hip hop. I'm gonna need a VNC viewer as well, because I don't think I have one. Nope. Windows, good. Save. Doo-doo-doo. Where's that UAC? There it is. VNC viewer. Yeah. Running without a password? What do you mean? How is that a problem? I guess I could do, is there a way to have this start? I feel like there's a way for this to start the session. Or set your display. Blah, 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 blah. Create option? Yeah. Damn right. Perfect. Lovely. What do you mean it's closed? Okay. Oops. Apt install. Netstat we need apparently. XVFB. Netstat Debian. Probably NetTools. Yeah. XVFB NetTools. Now we're hacking. If we got Netstat, wait until we get Nmap. Oh, we'll be taking down the Gibson for sure. All right. Let's see if that does it for us. You son of a bitch. Hey, we're in. Nice. So Vert Manager is basically not going to work unless we're in the right group. So Vert Manager Debian. So we're going to install those apps. Blah, blah, blah. Add user pleb lib vert. Okay. Looks like we're in. We'll make a... We're gonna have to copy in an ISO, so we'll do we'll copy in our Windows 7 ISO. We'll do our fuzzing on Windows 7 because it's the where we're getting the calculator from. So we'll do a PSCP. Where do we put it? Okay, here. This to that. Ten seconds. It's probably bottlenecking on disk rate, actually. It's kind of sad. I guess that's close to gigabit. Browse local. This. Forward. 64 CPUs. 100 gigs of RAM. 200 gig disk. We're gonna call this Win7 network selection. We don't want a network. Yeah, no. Okay, fine. Yes. Network. Where are you at? Remove. Bye. 64 cores.
Have you ever felt that way?
I have.
Looks good. CD-ROM attached. Win7. Is that not connected? This. Okay. Good. Put that on the IDE. Disk perf shouldn't matter too much for this fuzz case, so I'm not going to go through and set up the correct vert stuff. What keyboard do I have? It's a DOS keyboard with Cherry MX Blues. What's going on here? This stuck. I bet it's... Oh. It's not. It's, just the window size is fucked. There we go. Technically, we're going to need to meso the calc.exe, so let's grab that too. Downloads calc.exe. Delete the mesos for it. Keep this install going. I don't like this size. Scale to 100%. There we go. Jeez. The blurriness is driving me nuts. Go into IDA, grab this, spin up IDA, load this, failed to load PDB, yes. Let's see if I can find the PDB for that calc. Symbols, dev symbols, calc.pdb, this one. Looks good. Okay, we'll generate the meso file for this. Produce. What do I want? Script file, ida, calc.exe.meso, done. Save the database. Good. So now you have that. Looks good. All right. Oh my God, this platter. It's probably the IDE emulation. It's killing me here. It's hard to say if it's an emulation bottleneck or if it's an actual disk throughput bottleneck. Okay. 1, 2. Oh, you know what? I bet this is not going to be able to use all 64 cores. This is probably... oh, man. I think Windows 7 has a limitation to... I think it has a... like 32 core limit or something stupid. We might have to get server 2008. Probably do the trick. Actually, server 2012 also uses the old calc, but server 2008 would make more sense. Let's get prepared for that. Windows Server 2008 R2. Service Pack 1. That'll do. Oh, is that only the service pack? I think it is. Yeah, it's definitely not the full ISO at 1.9 gigs. I don't think server 2008 was that small. Maybe it was. I mean, that was longer ago. Let's grab this one. Let's see what this is. R2 with service pack 1. Oh. You can do that volume license too. There we go. Let's start. No. Download. Okay. There we go. 2.9 gigs. Must be served from a different server. It's a lot slower. Oh my god, it's gonna take 2 minutes? 2 minutes to download 3 gigs? What is this shit? Unacceptable. Have you played TIS 100? No, I'm not familiar. What is it? A puzzle game. No, I've never played it. Looks nerdy. Looks really nerdy. Looks kind of cool. Huh. Yeah, I've never heard of it. Never seen it. Never referenced it. So here we're going to get rid of the MU. We're going to move this. We're going to do en PSP en Windows Server. Fuck it. Copying might actually be faster here. So we might set up another VM for this. And then I can actually get the virtual drivers. So KVM Windows Virt driver ISO. require them to be, yep, get them from Fedora. This has IO. I don't want this complex shit. Just give me the fucking download. Let's grab latest. Let's live on the edge. I don't mind. I ain't scared. Probably don't have wget on this box. Oh, I do. All right. So we can start working on another VM here. We'll make this, gonna make this from a local ISO. Where is it? That copy done? Yeah. Refresh. There we go. Forward. 200 gigs of RAM, 64 cores, 200 gig disk, customize configuration before install, get rid of the NIC. We're gonna switch this to virt.io for the disk. The CD-ROM, we're gonna connect to IDE, that's plenty fine. That doesn't need to be fancy. So we're gonna do virt.io on that, tablet, blah, 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 blah. Virt.io, qcow2, probably about as good as we're gonna get here. Sound, it's fine, we can leave it. Everything else looks good. Virt.io will hopefully give us a little bit more disk performance than the IDE emulation mode. Obviously not during install, because install is going to be hitting the IDE emulation on the CD-ROM. But we'll take what we can get. So that's booting Windows there. We're probably going to shut down this this Windows 7 VM because it's probably going to be useless for us. Okay. Where we at? Here we go. Pleb. I don't know why this is not foregrounding. Whatever. No password. No product key. Ask me later. Looks good. Or am I doing the streaming on a VM? No. Nope. So we're gonna have a new calc. We're gonna have to meso out of here, out of the server instance. So if we take a look at this, we'll see that probably only gonna have a couple cores. Where is it? Where are my core counts? We'll just do a dxdiag. Yeah, this is saying two CPUs. What? Well, that ain't right. All right, this one will do server 2012, full installation of data center. Custom, don't have the driver, we'll have to browse. We gotta attach another CD-ROM. Actually, you're gonna have to swap this out quick. What do we have? VirtIO. This. Can now have this. Oops. Browse. CD drive. AMD 64. Windows 7. Load that driver. So I'll just shut down this this VM. We don't need it.
With Riku and me all the time. We played together on that island. His voice always used to be there.
Okay, so now that found the disk,
I can't think of his face.
now we
or
can
his
switch
name.
back to
I feel awful about it.
the Windows CD-ROM. Looks good. Connected in. What do you mean it can't be installed? Now it can. See ya. Bye. Close that. Ah, shit. Doesn't matter. It's still running. Hopefully this one can recognize the cores. Have you ever written a fuzzer where ordering or timing events and actions was important to you in order to find race conditions? Absolutely. That's like almost all fuzzers that are system level or of any target of reasonable complexity. So browsers, virtual machines, hypervisors, emulators, OSs, pretty much anything that's greater than 100,000 lines of code, race conditions, tucktaus, I guess they're a subclass. Ordering matters so much. So I actually have a tool that I've been working on for the past year that allows for deterministic fuzzing, and it allows you to replay things where even like one instruction ordering affects race conditions. So that is, it's a huge priority for me. It's pretty much the #1 priority actually for system level fuzzing. If you're fuzzing like a parser, yeah, you just want like interesting cases. Most fuzzers, most parsers aren't threaded. If their parser did have threads, then that would be in scope again, and that would be a big issue. So, just getting this guy set up. We have still never reproduced the like uninitialized memory use on exit. I mean, maybe that's because we have page heap on now. I could see that being the case. Waiting for this to install so we can scale up the fuzzer and have a dedicated place to run it for overnight or a longer time. I don't know. It's hard to say if I don't really expect more crashes with more time. I think we're getting almost all of, you know, with the coverage plateauing, crashes seem to kind of plateau. I don't know. It's hard to say. I guess race conditions are usually just over time. And I think a lot of the bugs that maybe we're running into in calc are race conditions. Not quite sure. Come on. Any day now. So much nicer on a solid state. I need to build a new storage server. This is outdated. This is so ancient. I guess the 10 tera platter isn't outdated, but it's a platter, so it feels outdated. Even if it's new. We could maybe start hacking on getting like keyboard inputs in. I really don't think keyboard inputs are gonna do anything. They're gonna increase coverage because they're gonna hit a different path. I guess that could have some weird interaction issues if you're like hitting the same button that you're pressing as a key. So there might be some things there. Let's add that as a thing that we have. So to basically add support for a new input, we have to first generate has to be able to make it. If generate can't make it, then we can't use it. So we're gonna add another field in generator. Okay. About to say, so we have fuzzer actions. We're gonna add another fuzzer action. This is gonna be a key press, and then we're gonna put this as key. Just gonna take a U8. Actually, we want to be able to do Unicode stuff here because some like really weird Unicode characters could potentially put us in a fun spot. So I think what I can do is key down. WM key down, and if it's a scan code, message is sent, virtual key code, see if OX41, yep, it's the A key. Those are just all the standard keys, nothing fancy. I think we can send arbitrary key combinations. We might not need to have a filter on it because since we're sending it directly to the window, I don't really care if it ends up exiting or doing something really malicious. So let me see if I have that implemented currently. Libs, actually, Twitch fuzz. Oops. GUI fuzz, source, win bindings, key press, key, and that's going to do a key down, key up of that key on a given window. So we're going to do key press. This is going to take a usize for a key. Then we need to implement that in two places. We need to implement it in our generator. So we need a random chance of a key press. So for the clicks, we're gonna now make this random, rng.rand and 2 is equal to 0. So a 50% chance of doing a GUI click. I didn't read that. I think maybe like 20 ballpark. Pretty solid. Cool, close. Then we're gonna do another 1 in 2 chance of inputting a random key on the primary window. So we'll do let key is equal to rng.rand as u8 as usize. So we're going to truncate it to 0 to 255. Then we're going to do press key. And we also have to log this actions.push fuzzer action key press key. It's already done. Press a random key on the keyboard. That might be able to hit the Windows key. I'm not sure if that's going to be an issue. Could be. Yeah, I don't know what happens if we send a Windows key to a different thing. Here we're gonna do key press, key, and all we have to do is press a key. Primary window.press key, press a key on the keyboard. Okay, this can potentially return an error. We're gonna ignore it. This one also, we're gonna ignore it. Look at that. Didn't even have errors. First try. Haven't seen... Windows hasn't popped up, so I think we're fine. I think this is good. So now we have key presses in there too. Looks like some of the calc windows kind of like disappear after some time. Whatever, it's fine. What happened here? Why did this shut down? Booting from hard disk.
I've loved you for a very long time.
Looks good. Coverage looks solid. Coverage increasing. One crash. Looks good. Hopefully this will scale out. I have no idea if it will or not. But boy, I really hope this scales out. We could also maybe find like where the animations are and maybe comment out some of that code or like make the animation speed like instantaneous. That could potentially be slowing down some inputs here. What was that? Failed to perform action. Could not find wind for PID. Okay. It's a shame. That happens. I think we're fine. I think we can ignore that. We can put this in release mode. Hopefully that will get us a little bit more perf. Decrease the overhead of the mutation and stuff. That was really good for a first fuzz run. Really clean. Surprisingly little coverage increase there. Come on. Where's the coverage at? That looked nice. Just visibly was kind of cool. $68.34 looks good. You know, we don't actually find ourselves in programmer mode a lot, which is kind of interesting. A lot of these inputs seem empty. Like, a lot of these cases seem to be doing nothing. I might add something that will pad them out. Let's see. Come on. 72.53. That looks good. I think we're a little behind. We're actually probably behind by like 1K. These are all stuck. Yeah, I might do some prints on the like number of actions that we're seeing. Man, come on, VM, wake up. Maybe it needs some mouse entropy. Some RNG needs some seeding internally. 72, 75 coverage. I could switch the key presses to only be numerical. Maybe that would help. What's up, the major? We're gonna decrease the chance of pressing a key on the keyboard. Actually, we're gonna have rng.rand mod 26 plus BA as U8. So we're gonna basically generate, we want 10 plus 0. So pick a random digit. So we're gonna have a pretty high chance of picking a random digit to smash on the keyboard. A relatively low chance of hitting any key. We're gonna put that to 1F. And then we wanna do a GUI interaction every single fuzz case. And 2. We don't want that. We want and 1. And then this one we'll just do this unconditionally. GUI access. We'll do a keyboard access. I guess we want some chance here. You always want some chance of not generating something. And 3, 1F. Looks good. 221 semi. So 0 to 10 is U8. Then we're gonna convert this whole thing to a U size. Done. Looking for specific crashes or generally breaking calc. Looking for specific crashes. We want to find an exploitable bug. We want something that can get us code execution. That coverage looks good, I think. I think that looks good. Okay, coverage looks fine-ish. Definitely typing a lot more numbers, which is good. Maybe I should just have it always sleep when we do the change. Actually, what do I do in... I might not have the replay doing the same things. Actually. Yeah, I don't want a rand here. We can't do a rand unless we can communicate that information with the fuzzer action. We want to look at menu action. We're gonna sleep for 250. Yeah, we were adding entropy in there that we weren't tracking. Not like it's a huge issue. I don't think the determinism is through the roof. But hey, I mean, anything that could be an issue, you never know. Well, those crashed pretty hard there. Why are these getting stuck? Why are these getting stuck? I'm gonna print out the input before we go. When we do generate, we're gonna give a 1 in that chance. Print mutated length is actions mutated.len. I think we might just be somehow converging to like very few actions. $592, $528. I feel like that's low. 478, 452. A little low, in my opinion. I mean, maybe that's all we're getting for actions. Well, those like stopped right away, and they're not stuck. I don't know if there's like some situations where we're like losing access to the window. Huh. We're gonna go into. We might maybe set the password. Come on, do I really need a password? You ass. Is that really all we're getting? Like in the generator case, if generate print generated, yeah, actions this, we're gonna do oh, we don't know until the end. Let GA is equal to this, print generated actions ga.len GA. I feel like that just seems low. Like, is that really all we're doing for actions? Get rid of these sleeps. Do you have any sleeps? Waiting for calc to come up. I'm gonna put this to 1250. Oh, we changed the wrong sleep. We'll change this one to 1500 actually. That was the intent before. Libs debugger source debugger. I'm gonna set the timeout to 15 seconds. All right, hopefully this one has some cores. Download install updates. They're not being installed automatically. Good. Yeah, there we go. Now we've got things in like the 20,000s, 50,000s. Hard to say if it's helping or hurting us. Don't really know yet. I think those sleeps might be useful on the animations. Yeah. I feel like without the sleeps, we're not seeing the animation swaps. Like, these aren't going into different modes nearly as much as they should be. Let's change that. Normally close the application. put this sleep back in. We're gonna try 75 millis. This one as well, 75. Give it a go. There's a little bit more variation, it seems. See if it is reflected in coverage. Yeah, it looks a little better. Not great. All right, Windows Server. Okay. Wait, did that say 32 CPUs or 32 threads? This has to support 64 cores. Come on. Come on. Processor, NA. That's an interesting processor. How do I get the number of cores? How do I know how many cores this has? Processor 34. Oh, there we go. That looks like 64 cores. That looks good. Okay, we're fine. $65.30. Man, that's bad. Do we need to sleep longer? Fine. We'll give you 300. 300 sleepy time. Maybe we need even more. I don't know. These animations actually look pretty slow. It's looking better on coverage though, I think, unless it plateaus. All right, so let's set up some networking on this. Come on. Yeah, it didn't look like the animation's finished. Yeah. So this we're gonna change. We're gonna connect in the vert ISO again. Good. We're gonna add a network device now. Network. Natted. Vert IO. We have no updates on, so we should be fine here. I just want to get RDP into this. I probably shouldn't have set so much RAM. It makes the initialization of the VM take longer, so it takes longer to start boot. RAM is just so punishing on boot times. It's so frustrating. Come on. Let me in. I want to hack. Send key, control delete. Nice. Guess we're gonna get the server manager. Yup. Networking, yep, none detected, that's fine. Device, manager, update, browse, disk, AMD 64, Windows 7, go. Really? Really? Net KVM. 2K8R2, AMD 64. Beauty. Nice. PCI device. I wonder if this will search if I just do D. Give it the big old D. Nice. And this one as well. Okay, so now this VM is like fully set up. There are no unknown devices anymore, which should be the best for kind of the setup. Ipconfig. Oh, am I gonna have issues due to NAT on that? I might want to configure that to be like a pass-through mode. Enable RDP. Select users, admin has access, good. Firewall, turn that shit off. Okay. So, is there a way that we can configure networking stuff? I think it's in here. Preferences. I know there's a, I always forget where it is. I know there's like a network. So this is all the different options. Nick. I guess we can do a host tap instead. IP adder. What am I running on? SO, I think. 65 SO. Looks to be where we're connected. Most configurations, MacView tab doesn't work for host to guest network. Yeah, I don't care. It's fine. Bridge it. That doesn't look bridged. Maybe it wasn't lying when it said it needed a reboot. Assholes. Making me reboot. I'm gonna actually do a force off. Force off. Yes. This should be using MacV tap, bridge mode. Looks good. Let it go. Let's see what happens. Come on, RAM. Do your thing. I just want to get this set up. Then I probably should head to bed. It's been a 11-hour stream. Come on. Hey. Hey. We got a real IP. Fuck yeah. All right. Now this should be much more usable. So we can close that. And honestly, close that pretty much entirely. Now that that VM is up and running, we don't really have anything to worry about. Oh, we got RDP. Okay. So cores, we've got all the cores. Does look like it found 200 gigs of RAM. Sweet. So let's see what happens. We're gonna need to grab the calculator out of here. Looks good, I love it. Let's get these things best performance. Turn off all the fanciness. No animations. No nothing. Okay, and we'll grab calc out of here. Windows System 32. Grabbing the calc. We're gonna push this into server 2008 R2. There's the calculator. We'll put this /program files, Windows kits, 10, debuggers, x64, sim check, calc.exe. Is that the same calc as we were using before? E9. It might be the same calculator. Yeah, looks good. Okay, we can just skip the meso gen. We can grab, make a new directory on here, fuzzing. Put the meso in here. And all we need now, I think, is just the meso's target. Where is it? Target, release. Mesos.exe, the PDB, might as well. Failed to create process, yeah, because that's trying to make Win32 calc. So we're gonna switch this over. Is it just these two places? Done. Okay. Oh, we don't even need the parameters anymore, I don't think. We can just run it directly. Paste this in here. Yes, yes. Got the calcs running. They're doing their stuff. Looks good. Looks good to me. Coverage is getting recorded. We already saw a crash. I'm gonna quickly see if this is real or not. There's a chance that the mesos for the calc.exe are not sane. We only kind of have good knowledge on the other one. What do we got? Null deref. Looks good. Looks like what we've been seeing before. Happy with that. Seems to be fuzzing. Coverage looks solid. Everything looks good. Just gonna get that killed. is it? Mesa, so it already exited. No calcs running. Looks like we're correctly cleaning up calcs. Now we just have to change a 4 into a 64. And cargo build release. Jeez. Oh, they didn't load in time. This might just bottleneck on rendering where there's like not even a point. Hey, I mean, we're getting crashes. So I need to come up with better logic. So Mesa's ended up panicking. Basically, the reason Mesa's panicked is we're having issues with attaching. So basically, if we're unable to get the PID, we're unable to attach. So let's get rid of the sleep. Those sleeps are fine because those are waiting for animations. This sleep we're gonna get rid of. We no longer, or actually that's the print sleep. This sleep, generator PID, and we're just gonna do I think we have window in here too. So while window attach PID, PID is error. Standard thread sleep duration from millis 10 up 25. So basically, while we're unable to attach to that PID, we're gonna sleep. There's a chance that if the process never starts that we never attach, but if that happens, there's some bigger issue. So basically, we're gonna wait forever until we're able to attach to that window. Window's not in here. We can pub use it just to make sure that that gets exported up. Now we have this exe pdb. Copy this in, replace them, get this running. So now it should wait until it can connect. We shouldn't get any of those enum fail. What the fuck? What's enum fail? That would be in libs debugger source, or that's probably in GUI fuzz source win bindings. Enum fail. That's fine. I think we successfully ignore those. So 106 fuzz cases. Coverage actually looks ass. Mutation length is that. I think rendering's a little issue here. I'm trying to think, like, if I hide the windows, maybe that will help. The enumeration fail is fine. We can ignore it. Mutated length is that. 199 fuzz cases, 5 unique crashes. I mean, the crashes are rolling in. So, you know, it's hard to argue with that. We got some panics going on. PID-TID issues. I think the OS is just not very happy with us right now. But, you know, that's... I guess that could potentially leave a calculator open on that assertion failure. We're up to 6 crashes. Coverage looks a little low. We might need to increase the time of these. Let's see what that CPU usage looks like. That's a good sign of CPU usage. But yeah, we have those panics. I don't think those panics are too big of a deal. CPU usage 5%. That means we're bottlenecking on the kernel. We're entirely bottlenecking on the kernel. The kernel is just not able to do this much rendering. Just, damn it. It must not be threaded in the kernel, maybe, to handle these interactions. It's kind of annoying. Definitely doing stuff. Got a new crash. Got another new crash. So we're at 8 unique crashes. We've had 181 crashes so far. I mean, I guess I can't complain. What is that? 8 unique crashes in 217 seconds, so like 3 minutes. That ain't bad. That poor kernel. Failed to join. We might be like losing threads over time. I'm not quite sure. I'm curious what would happen if I like closed RDP and it has nowhere to render. Do you think it's running faster? It's kind of hard to say, like, if closing RDP, so that will stop it from having to send all of the events over RDP. We could connect in this way, see how it looks visually on this. I think rendering is actually going to be slower here, but having it not rendering on any of the screens might be really good. This is pretty bad here.
Yeah.
304 crashes. Coverage actually went up a lot. You know what? I think that might actually be helping us quite a bit. So I'm going to RDP into it to kill that session. We're now in. That's going to stop rendering. This is back at it. I don't know. I feel like that made a lot of progress in that little amount of time that we were gone. Let's see, fuzzing. Right, eight unique crashes still. All right. So what do we have? We have the PID-TID assert, and we have a join assertion. I don't think I've ever seen a join fail. So we're going to close the RDP session. I'm going to let that churn. We'll check in on it. Check in on it in a bit. Enum fail we can get rid of. Just return out an error. That's fine. Basically, we keep trying that until it succeeds. We're going to up this to like 200 millis just to give it a little bit larger window. I think for our best case we did F there. We're gonna need to start doing some version control of these parameters and move them into like a constant database so we can keep an eye on them. Mutated length generator by get rid of some of the prints that will help. We have a join error here, failed to join thread. That's gonna pull down this thread hard. So we can do like a we can just do this if genres.is error. Continue. I don't know if that's safe. I don't know if that will leave the thread open forever. A little scared. A little scared if that's gonna cause threads to like stay spammed up, but that's fine. Let gen res equals gen res dot unwrap. Then we had a PID. Gonna assert here. We're gonna change this into if PID is not equal to 0, if PID is 0, or TID is 0, we're just gonna return a true to continue the enumeration. Probably just a race condition there. We have no other assert and win bindings, no other asserts there, no asserts there, no panics. Panic there, that's fine. I think we did one F here. Actually, we did like... Yeah, I think one F was the good one. These we did like 64 for the good ones. We can change those. 16. 16 is really stupid anyways for those. Delete a random portion. Repeat a portion. This is inserting a random slice from a donor into the vector. Update the input. And then this one is getting a random action and inserting it into the stream at a random location. Looks good. Linux is another machine. It's on one of my servers here. Buzzing. 8 unique crashes, 8366 coverage. That's really good. We're just gonna Control C mesas. I'm gonna try and get this killed. Might have to go into Task Manager to kill it. Bye. Looks like that took everything down nicely. Things look clean. Looks good. We built this new release. Right, built. Good. So now we shouldn't have any panics anymore. Hopefully, question mark. Since we don't have page table enabled, we might start seeing like more crashes actually. What is this? Failed to perform actions. Are we unwrapping that? We got to change that then. Failed to perform actions. Expect failed to perform actions. Okay, so mutate. The mutator I don't think should have any chance of failure at all. So I think we should be fine unwrapping that. For perform actions, we're just gonna ignore that result. Call it a day. Oh my god. How many calcs do we have? 170 crashes? Oh, we're churning fuzz cases now. Come on, exit. Mesos, kill it. Close this. 8 unique items. We're just gonna nuke these. What did we change? We changed... We're gonna go to the, on the action. When an action occurs, that sleep, we're gonna change this to like 750. We're gonna put that at 1F. Random key on the keyboard, randomly closing. We actually have to take this down. And this one we're gonna we're gonna do this unconditionally. Random key on the keyboard unconditionally as well. Or a random decimal key on the keyboard. That should increase the amount of actions we're doing. And then sleeps. Change that to 750. This one to 750 as well. And then to accommodate that, we're gonna go into libs debugger source. We're gonna change the debugger to have a different timeout. I think we had it at 15. We're gonna change it to 40, which sounds really high, but these fuzz cases are so slow now that we pretty much just have to change it. So that's gonna be 40 until we kill the process. Get us some more iterations in there. How long have I been working on this? 11 hours on this stream, plus I think 6-hour stream the other day, maybe a 5-hour stream, so we're at about 17 hours. 17, somewhere between 15 and 20 hours on this project. Okay, we got a new mesos. Looks good. So we basically up the time, we increase the time between menu actions. This selection we upped a bit. We tuned these to use a little bit more corruption. And is this random up to? Yeah. Yeah, it is. Okay. Looks good. And I think we fixed an assertion as well. So it's just waiting for all these calcs to spin up. They're gonna start coming online. We got some crashing right away. Not surprised. Definitely doing some fuzzing on them. The fuzz cases per second obviously has dropped a lot, but we're doing a lot more interactions, so we're hopefully gonna hit these a little deeper. Is that already 40 seconds there? Maybe 40 seconds isn't long enough. I just feel like they're not up and running fast enough. Yeah, we're like killing them before they do anything. I think once they kind of diverge and they start spreading out a little bit, error on generator. What? Really? Oh yeah. This will do onwrap or vec none or vec new. Basically, if it fails, we'll do the same thing here. Onwrap or vec new. Basically, we're gonna create an empty input if they panic. We just want more panic resilience here. Kill mesos, build it. We're gonna up the timeout now to 90 seconds. Can you explain in 4 sentences what fuzzing is? Generating random inputs to an application to see if the application fails. I guess that wasn't 4 sentences. But it's usually just the act of mutating and corrupting known good inputs, passing them to an application, and seeing if the application correctly can handle them, or correctly errors out if there's an issue. Yeah, that's effectively what it is. I'm gonna close this and see what happens. We'll check in on it in maybe a few minutes here. I'm gonna refill my water quick. I'll be right back. All right, let's check in on it. Coverage mediocre, 29 crashes, 2 unique. Looks like somehow it seems like it's doing worse. Huh. It just might be too many calcs. It doesn't seem to scale linearly with cores. We could try fewer threads. I don't know, we had... It's hard to say. Like, with the low timeout, I think, what were we running the first time we deployed it out? Like 15 or something? I changed too many parameters here. 750, we're gonna drop that back down to 250. See if this has an effect on it. I don't think viewing it in RDP is changing it. Let's go. Okay. Bunch of crashes, a lot more fuzz cases, terrible coverage. I think these are just not doing anything. I think when we saw like the 8,000 coverage, I think that was just... I think due to the panic, some of the threads died, and that caused fewer processes to be running, which actually made it a lot better. So we're gonna drop this down from 64 to, we're just gonna try 10 threads. I just wanna see if that's gonna make it better. So that was like instant, all of them were up. Why is it not doing anything? Let's kill it, see what happens. Something's going on here. They're all coming up, but why are they not fuzzing? Print can now attach. Change this back to a 3. Maybe they're panicking now, and I just don't see why. Yeah. So we're getting into there. Oops. Generator. Attach. Generation. Print left click action. Is there something I broke? Is there a lock I'm holding? Maybe my mutation logs are an issue. Probably not. Attach for generation. Okay. Okay. Then where are we getting stuck? Is it always failing to enumerate? Failed to enum sub windows? Okay, well, that's an issue. Failed to enumerate subwindows. Enumerate subwindows. Fuzzers win bindings. This. Enumerate subwindows. Enum child windows. Let's see if we can do a continue here. Oops. Left click action. I'm curious if it's like failing sometimes. You know what? I think it's not. Oh my god. I think it's not attaching to the I think it's not finding the main window. I don't know what process I just killed, who cares? I think what is happening is that if I print out hexadecimally what the primary window.wind is, and we take a look at what the window handle is, what? Isn't it wind? Oh, it's private. We're in a different thing. We'll just hex. There we go. Failed to print, or failed to enum. I bet we're gonna see this. Yeah. So these window titles are not correct. I think what is happening is we are attaching to sub windows. So I remember this. If we look at enum windows, this had a really gross thing. Note, for Windows 8 and later, enum windows enumerates only top-level windows of desktop apps. So, since we're now on server 2008, which is prior to Windows 8, we're probably attaching to a random text box in a calculator window that matches our PID. We're no longer attaching to the parent window. So, let's see if there's a way of enum windows, check top level. Otherwise, we can pass in a name. Doesn't find some top level windows, enum windows. I'm trying to figure out if there's a way to see, like, if there's a parent window. MSDN, get parent, wind, and I think what we want is, if we open up SPY, we should hopefully see that the parent for calc should be the desktop. So we should get desktop window. Why don't you use server 2012? Doesn't have calculator. Actually, server 2012 does have calc, but I'm just trying to kick it old school. Get desktop window, MSDN, wind, good. Now we're gonna say enum PID. So we're gonna say get window thread process ID. Here we're gonna say if wind, if get parent of wind is not equal to get desktop window. Continue. Skip windows that are not parented by the desktop. aka skip non top level windows. We just need to make a binding for this. Usize, usize. Right? Because if we open a calc, if we open calc, we should be able to find that in the Windows listing. Oops. This, synchronize, and this is parented by the desktop. So I think that should do the trick. If get parent is not equal to the get desktop window, continue. Okay. So that should be an improvement. Get desktop window, not from the scope. Yep. Yep. Get desktop window. That just returned to usize, right? Yep, no parameters. Okay, 159, can't continue. Yeah, we want to return true, which is continue the enumeration. 158, these are all unsafe. Okay. Boom. Son of a bitch. Is that not finding the windows now? Are you kidding me? So we'll switch it to .8. We're gonna .8 or 10. Switch this to single threaded mode, and then we never attached. So that's now failing. Let's we'll get this going. Print skipping due to X parented by X want X. So unsafe. Oops. Here we'll do get skipping due to Wind is parented by get parent Wind, and we want it to be parented by get desktop window. Okay. This is gonna be really spammy, really spewy. And let's we can print. We're gonna debug print the window, this one. We're gonna say wind, window wind. So we're gonna make that internal. So that way we're gonna be able to see the window name of that, and we're gonna probably end up copying in. Okay, so here's what we got. Got all these things. We're gonna pop CMD open here. Mesos.exe. Control C it. Okay. Default IME. Yeah, so that's open. Calc's running. Kill Mesos done. So we should see in here somewhere there should be calculator. Closing. Here's calculator. Skipping due to this. Parented by 0. Want this. So these are parented by this. Maybe we check for 0 instead of get desktop window. If it's not equal to 0, let's check what. If it fails, it's null. Okay. We could also search. We could also check that it's the calculator application. but I think this should be fine. So now we're gonna say if get parent is not equal to 0, then we're gonna skip it. And hopefully we're now fuzzing. Okay, failed to enum sub windows for that window. Let me run mesos here. Okay, attach for generation. So we ended up attaching to 87114C. Should just be like the last one we saw, right? Not quite. 87114C. Where's calc at? Oh, it might not show up here. Okay, we'll filter by the window name. Fuck it. I just wanted to get creative. So we don't need these anymore. Get parent. We can kill this. Enum window handler, that's now taking in an extra parameter field. This is going to be a string, which is the window title stir. This will be window title dot into. We're going to pass that in, and then text, window text. So then we're gonna do PID. If PID is 0 or TID is 0, return true. Yup. If the param 0 is equal to the PID, then we're gonna see if param.2 is equal to we're gonna do if let OK title is equal to self dot window text. Oh, we're gonna need to pass that in there too, aren't we? But we don't have a self yet. We'll have to create a temporary window. So we can do temp win is going to be equal to window wind. So we're going to basically create a new window object for this. Then on this temporary window, we're going to try and get the window title. If we're able to get the window title, if the title is equal to param.2, then we have a match on the title. And then, and only then, will we fill in the parameter. So create a window for this window we are enumerating. Get the title for the window. Check if the title matches what we are searching for. Match. Keep enumerating. So in all cases here, we want to return true, keep enumeration going. Okay, attach PID at 52. It's now complaining. We also need here we can just say calculator. Attach PID here. Calculator. Attach PID here. Calculator. No field 2. That is fine. This is this also takes in a string now. Nothing to compare those two. Fine, ref them both. All right. I think we made it. Boom. Left click action, good. Failed enum sub windows. Window hind. That got stuck. That clearly found the right window. It's doing a lot of stuff. Looks great. Then we ran into an issue where we get stuck on failed to enum subwindows. 631. Failed enum subwindows. Failed to enum subwindows. This basically happens on this situation. Why is the... How's that happening? How's there no title on that? Failed enum subwindows. Which is causing it not to relaunch. Maybe? We can try this. We can just see what happens. I just want to see if this is going to get spammy. Left click action, failed enum. Now we're stuck in this state. Okay. So I think the return is fine here. That basically means the calc window is gone. And then this is gonna be print join error. This might be an issue if we're hitting a join error here. Otherwise, we might be waiting forever for the join to occur. We're gonna put another print here, joined. For some reason, we're not starting a new fuzz case. Left click action. Joined. Well, in that case, I killed Mesos. So we're gonna get Mesos running. Performing actions. Where's calc? When I control C, I get joined. Mesos. Calc is open. It's doing its stuff. And at this point, that returned out. For some reason, the thread's still running. Joined. Good. Oh, maybe it just took that long for it to exit? Now what is it doing? Calc's up and running. Joined. Okay. I think it's working. I'm gonna add a small sleep in there. Well, yeah, I think it's working. Join error, joined. Print. No more prints, no more prints. Looks good. .1. Change this to, let's go up to 16 threads. Copy these in. See what happens. So, definitely connecting to those. Looks like some of them are idle. Is it struggling to find some of those windows? Took them down. I don't know why some of them are doing nothing. I mean, we could switch to Windows Server like 2016 and use the Win32 calc. Maybe we get like, maybe these APIs just play a little bit nicer. 8 crashes. Actually, coverage looks really good. I think they might not be rendering sometimes. 6900. We can see if maybe this fixes the issue that we had before. We can try all 64 cores, give it a whirl. We could potentially hide those windows too, and maybe hiding the windows would prevent the rendering. Okay, got a crash. Making no progress because they're not opening. They just can't. They just can't keep up. Six crashes, one unique. Okay. Mesas, kill it. We're gonna throw sleep in after the attach PID. And then in these situations, when we do attach PID, those are failable. I guess maybe sometimes it's just failing. Maybe I need a retry on attach PID. I could also try and find something, some like Oracle, some breakpoint to set with mesos to like don't fuzz until this has occurred, like it's shown up enough. That was kind of the goal of this, but doesn't seem to be enough. We're gonna add some RNG onto this. Mod 5,000, and we can just do that base. This will kind of stagger some of the launch times of them, which will hopefully staggering them will maybe help them start up because they won't be all hammering resources at the exact same time. RNG rand in 3. Yep, we'll just make a new RNG. It's free. See what happens. Oof. Oh, there's one. Lots of crashes. Okay, we're gonna kill it. Bring down mesos. Let's go back to 16. This might be a hypervisor target. Might have to spin up my hypervisor for this, because otherwise, we're just not getting linear scaling with cores because Windows just can't handle the amount of rendering and traffic that's going on. Generate, we'll put back to F. Put that with the random. Looks good. So that's looking nice. Was that 16? We even did some valid conversions. 5,600 coverage. 3 crashes, 1 unique. 5,800, 6,400. 4 crashes. I mean, these look pretty solid here. Was this 16? We could try and push it up to 20. Maybe slightly increase the time that calculator stays alive. Looks like all of them are getting mutated correctly now. 14 crashes. Yeah, this is looking good. We're gonna maybe try and go up to 32. 32 might be a good number because that will mean that there will be one kernel thread for every. There will be one thread doing nothing for every thread that has a calc and a fuzzer running. Actually, we spin up a fuzzer thread as well. I'm curious if we're bottlenecking on the lock. I don't think we are. This input generation is a joke. Now, we might be bottlenecking on allocations. We might be actually hitting so many allocations that we're causing some serious thrashing with allocations, so we might need to make allocations persist if we want to scale to this. What else? What else could be an issue here? Yeah, we'll grab these, throw them in here. This is now doing 32. And let's up the libs debuggers source debugger. We'll update this. I think we set it to 15. We'll put this to 25. I think a little healthier timeout for that. But yeah, I'm guessing we're just thrashing allocations really hard. That might be causing some issues. That might be causing a lot of virtual protects to get called, or virtual Alex to get called, which then could be causing a bottleneck in a different area of the kernel. So we do see the calcs coming up. It's been 8 seconds. Coming alive. I don't necessarily see 32 of them. They're not changing modes. We're probably going to start killing them pretty soon here. Yeah, there we just killed them. Here they come up again. Yeah, I need to stagger their launch times. Right now I'm staggering the attach times, but that, I mean, that has no effect. So let me change that. Mesos. Sleep. So we don't need an RNG here anymore. And we're just gonna stagger the launch time. Oops. We're gonna stagger them by up to 5 seconds. That should be fine. Maybe that makes a huge difference. We can also stagger them correctly, like up front, but this will like keep them randomly shifting around. So yeah, we have some up and running right away. Come on. Yeah, that didn't look too good. Coverage was really bad too. Yeah, where are we losing our CPU? I mean, you could click away from RDP and see if we come back to like a lot more coverage. Let's see what happens. Alright, let's check in on it. Coverage went up quite a bit. 3 unique crash, 3 crashes, 3 unique. Yeah, it's not working. Okay. It's just not gonna scale. That's really annoying. Kill Mesos, and I guess we'll drop it down to probably 16. I could look at like a kernel profiler to see like where in the kernel that we're losing our CPU time, and that could maybe guide us into finding a better place to focus. Or like if we see that the kernel is locked up because we're enumerating windows too much, then maybe we need a better way of doing this. It's hard to say like which API is causing these issues because we're not using any CPU. We're pretty much getting stuck in the kernel probably in just locks and stuff. So 16 looks really good. We're already up to 55 crashes in 30 seconds. Only one unique, but coverage is looking good. This looks pretty solid. Coverage increasing. '81 crashes. Still only the same crash. Same crash every time. Trying to think if there are any tunables worth changing at this point. I don't think so. Got a second crash just came in. Another crash. Up to 3. 7K coverage. A little bit low. 7,500. Now I'm not complaining. $7,700. 158 crashes. Still only 3 unique. I can't remember if there were any tunables that we changed that, because I know we hit like 7 or 8 unique crashes pretty quickly. We are at 7,800 coverage, which is good. Fuzz cases do look like they're going deep. Looks like some of the calcs are getting stuck, which is good. We want them to run until they get stuck. We want the timeout to kill them when they're frozen and misbehaving. We don't want the timeout to kill them when they're in the middle of doing something valid. There we just did a calc, like one of the long pop-ups. Just got another unique crash. 7,900, about to cusp 8K. We could also add code coverage for non-calc modules. We could look at coverage in like all the DLLs that are loaded as dependencies, and that would maybe give us another few like things to hook on. We just got another new crash, up to 5 unique crashes, 270 total. That looks pretty good. Coverage looks solid. It's probably, coverage is a little bit low. It's probably a way that we could get that slightly better, but it's not a big deal. 8,200 coverage. I don't know if we've seen that yet. That might be higher than anything we've seen. 8,193. Actually, I think we've seen like 8,500. Let's grab fuzz stats. See if we can copy that bad boy out. Let's see what it looks like. So yeah, it's underperforming, but it's got like a pretty good growth pattern here, which looks nice. 8,195. So it looks like our max coverage is like up in this area, about 8,700. It's also not necessarily apples to apples because this is a different calculator technically. I don't think they would change really a significant amount for like the amount of blocks, but you never know. So we could play around with some tunables and see if there's some better perf we could get. Looks like they're doing pretty chaotic things. I think I might want a relatively high random chance of like resetting the calculator back to the default mode, because it looks like sometimes they do get a little bit more stuck. 8337, 38. So we have a lot of inputs. This is kind of an issue you have. The more threads you have, the more opportunities you have to rediscover the exact same code. How is instrumentation done? Instrumentation was done with a tool called Mesos. github.com, mesas. I can just search for mesas. You can find it here. $8,300. 5 unique crashes. I think we can do a little bit better with tunables here. And I think we might be better with fewer threads. Just a smidge fewer, like going down to 10 instead of 16. So let's play with some tunables here. Shouldn't be any rands in there. The 15-second timeout seems to be working great for us. I kind of remember that from a previous one. Input selection, that generates a random one. This is the number of corruptions, so let's decrease the corruption amount. The selection, we're gonna put this back up to 8 such that we can do more of these. Then everywhere we do a rand, let's just take a look. Up to 64. Let's drop that down to 32. Same as this one. This one. This one. This one. Okay, that looks good. So you have a little bit higher chance of doing these random actions. This stagger, we can drop down to a second to kind of decrease that. Generate, we can go to 7's probably pretty good here. Actually, I think 3 is fine. 1 in 4 chance of creating a new input. Sounds good to me. Those are the only rands there. And then everywhere here. Random input, correct. Up to 16. Select up to 8. Select up to 32 of these to slice. Select up to 32 of those to slice. Slicing here. Slicing here. Oh, this is repetition. We want massive repetition potential. Rand up to the input length for the insertion point. Up to 32 for that. We're gonna see what this looks like. Okay, smash this in. Oh, it's apparently still running. 7 unique, 8428 coverage. Okay. I'm kind of glad we kept that running. I didn't realize we did. We're gonna make a copy of fuzz stats. This is gonna be like a decent run. Just so we have another reference point on this machine. Let's get that up and running. We didn't change it to 10. Let's see how this does on 16. We'll change it to 10 if it looks like it's falling behind. Coverage looks good. Two crashes. Coverage actually looks pretty trash. Did we really make it that much worse? Or is it just spinning up? The crash count is much lower. The coverage count is much lower. Maybe we had a good thing going there. Okay. Kill it. We're gonna drop it down to 10, see what happens. Actually, we'll go to 8. We'll go like extra low. I just want to see like the extreme opposite behavior. Interactions look a little healthier. Yeah, coverage looks really good there. Coverage looks a lot better I don't know if that's just a crazy fluke or if it's just much better with this many threads. Which sucks, because it's like literally... I mean, we could spin up VMs. I could maybe make more VMs or something. And then do 8 per VM. Make 8 different VMs. This is definitely just performing better. At least for coverage, not necessarily in crashes. We only have 1 crash. Visually, it looks like they're quote-unquote doing more. Not that that means anything. $77, 7,800 coverage. Where the crash is at? Over 8,000. We just got our second crash finally. Five crashes. Still only 1 unique, but 8,100 coverage. It's hard to say, like, what affected that. Like, the coverage is much better. Well, now it's up to 4 unique. We just got 2 crashes really fast there. $8,200. It's not too bad. I don't know. I'm gonna revert basically everything I just did. I think this is what we were on. .16 looks good. Reverting all of this stuff. I think this is where we were. Because this was just giving a large crash frequency. Like a large amount of crashes. And quite frankly, that's what we care about. What's going on with this RDP? Looks good. Okay. Up and running. This is going to start 16. Some of those look stuck. Coverage looks... it's only been 1 fuzz case. Coverage looks good. 1 crash. Two crashes. 3, 4. Coverage looks good. Unique crashes looks really good. Number of total crashes looks really good. Yeah, this seems better. I don't necessarily know what is better about this. I mean, we're at 4 unique crashes at under a minute. I don't know why. Can't tell you. 61 fuzz cases, 4 unique crashes. That means we're getting 1 unique crash out of every, like, 15 fuzz cases. Which is a really dense fuzzer. I don't know why this is so much better. Maybe it's a crazy fluke? How do you generate the data that you pass to the calculator? We enumerate all of the different sub-windows, which includes like the buttons and edit boxes and all those things, and we randomly send mouse events to them. So we basically learn kind of the UI layout of calculator automatically, and then we just spam every button that we know exists. Crashes. So we've realized that when we decrease the thread count, we get more coverage kind of in a denser manner. I'm gonna try, that's gonna be the only variable I'm gonna change. Actually, let's do another run of this. Let's see if this is relatively similar run to run, because maybe we're trying to find signal in a massive field of noise. So 1 unique, 2 crashes. Coverage looks good. Coverage looks really healthy this run, exceptionally healthy this run. 2 unique crashes. Similar to before, we're getting them very soon. The other one I think hit 4 by 60 or 3 by 60, something like that. And most times we run the fuzzer, we get 1 after 60. So if this hits 3 or 4 around the 1 minute mark, I think there's just something good about this fuzzer configuration. No idea why. 2 unique. That's kind of hard to say if that's an improvement or not. 8 crashes, 9 crashes. Crashes coming in nice. Coverage looking pretty good. Unique crashes looking fine. We might be optimizing noise. 3 unique crashes and 80. I don't know. I feel like three unique crashes is something that we often don't see after a few minutes, and we're hitting it in a minute on these bad boys. So let's drop that down to 8 threads. See if that increases our performance here at all. That will potentially increase the amount of stuff we can stress. Immediately 3 crashes, 6 crashes, 7 crashes, 10 crashes, 11 crashes, 12 crashes. Okay. So a lot of crashes with 8 threads. What is this? Unique count's not going up. Coverage is not going up. Now we have some like popping up. Like so many more crashes. Maybe a lot of these bugs are race conditions and just aren't going to hit many threaded because there's just like too much delay in certain operations of the calculator. Got a couple unique actions out of that. It's just generating so many crashes, but not unique. It's kind of hard to say what's going on there. I'm gonna go down to like a single thread. We'll go down to 2 thread. You know what? Fuck it. 1 thread. We're gonna see like the extreme non-scaled operation. I'm so used to like snapshot fuzzing at this point that like live fuzzing, basically live fuzzing is when you're fuzzing against a system, multiple threads, all these things. Snapshot fuzzing is when you're fuzzing something in a VM such that you can revert it. It's deterministic. You get linear scaling because you have a copy of the kernel for every single VM. So coverage looks a lot higher here. Okay. Okay, and we can try another extreme. We can go up to 32. The 16 seemed to be a magic number, so we might just do that if we can't find a better one. And then we have a 5,000 in here that we can get rid of. We can definitely make this 1,000. Actually, even 500. We just need jitter. It doesn't matter like if there's a long delay or not. We're looking for noise in there so that they kind of start launching at different times. Oops. Yes, yes. Go. A lot of calc windows, terrible coverage, 0 crashes. They're just not coming up fast enough. Was it 10 or 16 that was magic? We'll try 10. But yeah, if we put these in VMs, do some snapshot fuzzing, we'll probably get much better results. Switch this down to 10. And yeah, I definitely don't like this F. Like 7 at most. I think 7's a lot better. Increase the frequency of generation, which allows us to learn the display a little bit better. And it's still 1 out of 8 are being generated, so it's still like a pretty good generation rate in my opinion. Paste, paste. Here they come. Looks like they're doing really good stuff. We got 2 crashes already, 3 crashes. So crash counts look good. Coverage looks good. Unique is already at 2 at 20 seconds. Three in 30 seconds. 4 at 40 seconds. Man, if we can get a crash every 10 seconds, this is gonna be great. Four unique in 40 seconds. I think that's the best we've ever seen. So this might be the miracle configuration here. 5 unique in 60 seconds. Holy shit. 7,100 for coverage. I don't even care about coverage. If we're getting this many unique crashes, I can't say that I care. That's insane. Is this the same stream as last night? Yes, it is. How old am I? I am 26. It's looking good. I'm not even complaining that it hasn't hit 6 yet. I wouldn't expect that. Crashes are always logarithmic. It fucking hit 6. It hit 6 in 2 minutes. Man, this isn't even skill. 7. What? That's unreal. Well, 8, if it hits 8, then we'll be at parity with everything we've ever found in like a couple minutes. We just hit 8K coverage. Looks like healthy growth there. Unique actions look like they peaked out. That's what I'd expect. Still at 7, still happy. Coverage healthy. Coverage hasn't gone up in a while. Crashes are still healthily increasing, which means we're still exercising crash like dense areas. As long as I see the crash count going up, I know that we're recreating good inputs to fuzz through. Eight unique crashes. I think that's a completely unique one. That's one we haven't seen. 1898E. That looks kind of close to others, so it might not be too crazy or too special. We just Nessied up to 8200 coverage. I don't know. I'm pretty happy with this. This might be the one that I leave overnight. Like, we know we can hit probably up in the 8800 range for coverage. Hard to say. Like, we've observed 8800 on the Win32 calc. I don't know if that's possible on this specific calc. It probably is. I bet this will hit like 9200 overnight. That will slowly eke its way up there. At this point, pretty much any new crash that comes in that is unique will be new to us. So it looks like I have 9 crashes in this folder. This, select that. I have 9 crashes. So technically there's 1 crash that this has not found that we've seen before. If this goes to 9 and we don't get a new file, that then means the next crash would be fully unique, something we've never seen. There might be some in here that we've actually never seen before, but I'm probably gonna hold off on looking through these until tomorrow because I wanna look at them all together, and I really don't want to cancel this fuzzer because even if it's like some magical thing about it, some weird state, I'll take it because it's working fantastically. $82.33. Still 8 unique, but that's fine. Like, 9 unique. We just got a new one. The address looks completely different from things we've seen before, so that one might be a completely new bug. How are the inputs determined? Completely random. Everything's random. There's no order in this. There's no logic, really. Could definitely improve this by like telling it to do things in certain orders, to do operations in certain orders, increase the frequency of like number generation. We're at 10 inputs. So this now has found every single bug that we have in this folder because we have 8 down here, we've got 2 up here. So at this point, any bug we ever find from this point on will be a new bug. We just Nessied from 8239 to 8348. That's a pretty big jump in coverage. Hell yeah. 8350, 8354, 863. Still getting new coverage coming in. We're still finding unique actions, which blows my mind. Basically, that means we're finding different things to do in calculators, so we're getting new dialogues or new states that we haven't seen before. $83.74, $84.06. Love it. Let's grab this fuzz stats. Let's see where it looks on the graph. It's going to be a little bit behind, but that's not a big deal. I pasted it in there? No. See. Getting this file out might be difficult right now. There we go, got it. So we've got like really clean growth throughout fuzzing. Obviously we're tapering off at the end. That makes sense. Not too big of a deal. 8441, so we're still getting like small increases. Let's move this to a spot we can always see. I think here we can always see. You have no idea what's going on. So we are trying to find bugs and crashes in the calculator application. And to do that, we are generating random inputs and randomly hitting buttons and keys and all this stuff on calculator. And that's why calculator's like freaking out, showing all these weird numbers and going on all these different modes. We're trying to exercise as much as the calculator application as possible to try and find weird states that the developer overlooked and made a mistake and implemented a bug. That's effectively the goal here, is to find unique crashes. So like this 10 unique is basically what we're looking at the most. Coverage is kind of telling us how much of code we've exercised. Could you exploit these random bugs? We're gonna probably exploit whatever bug that we find that's exploitable. So far, none of these look to be necessarily exploitable. There's one or two that might be. And those are unlikely. Actually, yeah, I would say there's probably like a 5% chance that out of these 10 unique bugs that we found so far, that any of them are exploitable. So basically, I don't think any of these are exploitable yet. Hence, we're looking for new, better bugs. How is coverage measured if inputs are completely random? I've basically hooked on the application such that I'm able to... That's interesting. Crashed with a different exception code. This was a stack exhaustion. COFD. But basically, I have a custom debugger that puts a breakpoint on every single piece of code in Calculator, and then as those breakpoints are hit, we record what has been hit in those breakpoints. You know what? We're actually probably bottlenecking on the breakpoint API stuff, because every time we launch a calculator, we apply like 30,000 breakpoints. And that's maybe why we have 0% CPU. Because the kernel, I bet the debugging API stuff is not written with scaling in mind. So there's a good chance that could be killing us right now. We just got another unique crash, 2AC. That's pretty similar to some of the others. So that one might not be unique. It's hard to say. Let's see if we can grab some of these out. This is archive run. I don't know if I got my Control C off, or even if it supports copying this many files. Did we just hit 12? No. What am I copying? A5. Okay, so they're coming in. Slowly. Next up, fuzzing Minesweeper. That'd be kind of fun. So page heap is not enabled, so there's a chance that we will start seeing different variants of the CO crash that we know of before. That's fine. We'll just see different places where the bug kind of trickles up. Sometimes actually seeing the different ways things crash can be interesting, because it tells you maybe you didn't think that a bug was exploitable, but you didn't know that somehow it could cascade into causing another issue, which caused another issue, which was then actually exploitable. So I've got all these. Looks good. Although I would expect like a read high. I actually don't know if we've seen the, I mean, well, that's fucked. Pretty bad. Okay. All right. What's next? Null deref. Null deref. Null deref. Null deref. Null ed. Null deref. Null deref. Null deref. Null deref. Null deref. So this is the only one that's kind of interesting so far. Do you have something to reproduce inputs? Not really. We could figure it out, but not really. It's not a huge priority. I don't really worry about reproducing inputs until I get real bugs. Until I get bugs that I actually care about, I just don't really worry about it. So in this case, bad food, I'm guessing is what is bad food? Is that I don't think that's uninitialized. I think that might be freed. Let's just Google Windows 7 allocator. Oops. Windows 7 allocator OX bad food. Come on. It is that, right? It's bad food. That's what we saw. Bad food. Allocator, Windows, reversing. I'm looking for slides, basically. Debug heap CRT. Okay. Is this using a debug CRT? Is always initialized to the 4-byte pattern. So this is, yeah, that's the uninitialized memory use. Apparently we have like a debug CRT being used. Actually, let me look at my cargo toml. And which is the interesting one? It is 5A5. We found that one relatively early. I just want to turn this off. I don't want the uninitialized thing in there. So let me see. Cargo config, CRT static. I don't know how to switch it away from using the non-debug CRT then. CRT static Rust. Yes, this is all in Rust. On Windows, is there any way to set it up and clone it? There's not really a supported way to do it. There are some hacky ways that make it kind of theoretically possible. But for the most part, no. Unfortunately. But yeah, to get this to scale, to use all the cores correctly and to set breakpoints, and to gather coverage correctly, I can use a hypervisor, and then we can avoid like a lot of these issues, and we can switch over to a snapshot-based deterministic environment. So we've already gotten this in a pretty good state. I'm actually pretty happy with this. I think the next step will be to convert this into snapshot fuzzing. And I think this is a perfect example of fuzzing. We started off with something really basic that works single-threaded. We then made it more advanced. We then maxed that out, so we added threads, ran into some scaling issues, and now we're questioning, should we turn it into a snapshot fuzzer to get a little bit more information out of it? And I think yes, that's the direction to go. That'll allow us to basically have a VM per core, and we'll probably get scaling that's almost directly linear with number of cores. So then, instead of being at elite fuzz cases right now, we would be at probably 8 or 9,000 fuzz cases. So we'll probably look into doing that on another stream soon. I think I'm probably gonna call it for the night here. Pretty happy with this. Just gonna let it run. 11 unique inputs. If I woke up in the morning and this is at 15, there's probably a pretty good chance that there's some like crazy bug in here. There's a chance that there aren't any more. Like there's a, I would say a greater than 50% chance. Like it's probably more likely to happen that I go to bed, sleep for 8 hours, come back to this in the morning, and it's at 11 inputs and 8,900 coverage. But you never know. You never know. So, yeah, I think I'm going to wrap it up here. Thanks, everyone, for tuning in. This has been a blast. I'm excited to look into making this even more complex, more advanced, maybe get some scaling, maybe do some work on a hypervisor to get this to work. So, sweet. Thanks, everyone, for tuning in. See you around.